on a disk floating through space with a tiny sun.
Hey guys, I'm Team Skeptic, and welcome back to the channel that does to stupidity what Tanya Harding did to Nancy Kerrigan's kneecaps. With me today, I have JM Truth TV. How you doing today, JM?
Where's he gone?
All right.
I'm here. I'm good.
Okay, I was about... Okay, JM, are you there? Okay. Introduce yourself, your channel, and let everybody know who you are.
Hey, my name is Joshua Michael. I run jmtruth.com and JM Truth TV and JM Truth Radio TV. I guess it is what it is now. Doing a film production called The Plain Truth, and you can find us at theplaintruthmovie.com on both Facebook and YouTube. And I'm looking forward to this debate.
All right, well, today, today with JM, we are going to have him debating our esteemed host of this incoming flaming dumpster of shit, Fight the Flat Earth. How you doing tonight, FTFE?
I'm doing good. I've been preparing all day for this, actually. I've made a lot of notes and preparations. I know exactly what I want to say. I have no idea what JM's going to bring, but I'm going to try and stay on topic is my main focus for tonight. On topic, no getting sidetracked. So yeah, let's do this.
Nice. And then we have Furball. I'm just kidding, Furball. Let me give you a proper intro. Oh, the joke must have just gone right over his head. With us today, he's going to actually be moderating. I'm just here hosting. He's going to be moderating. We have BM Furball, a fellow member of the Armed Services. Pleasure to have you here tonight, sir. I've watched your stuff. I've watched your debates, your interviews. It's all great shit, man. People need to be subscribed to you, and I see that it's growing rapidly. Good for you.
Is your mic on, dude?
You're muted.
Why did I do that? I'm an idiot. Thank you for inviting me. Thank you for letting me be the mod. Yeah, I'm at about 1350 subs right now. The last couple of weeks has been a pretty good uptick thanks to some help from Craig a couple of weeks ago. So glad to be here.
Yeah, can I just say that BM Verbal is a bit of a hero of mine at the moment. The things that he's been doing, especially building his own Cavendish experiment in his apartment in Korea. I've been paying close attention to it, and I'm going to be doing like a half-hour video special once he's got all the data and everything in on like what he went through to make it and what he's been able to do. If you guys haven't checked out BM Verbal, seriously, do it, because he is very different to me, but in a way that's very much needed.
Thank you.
And let's kick it over to you, Furball. Why don't you get this debate started?
All right, so the format for today's debate that both of the parties have agreed with is we will have 5-minute opening statements from each party. Then after the opening statements, each side will have 10 minutes to present evidence and a debunk. Then after that, there will be 20-minute rebuttal, followed by a 45-minute discussion. After that, we'll have some chats and closing statements. And what they've both agreed to is that both participants must present one positive evidence for their side and one debunk for their side. So those are the terms for everything. Yeah. Do we want to start with JM? Would you like to go first?
Just to clarify, we get 20 minutes for our presentation, so 10 minutes for evidence and 10 minutes for a debunk.
Okay, sorry.
Yeah.
Okay.
Okay, well, this will be interesting. Apparently I missed it, but I missed the debunk part of it.
So. That's all right. I'm sure you can think of a debunk for my side on the fly.
Oh, it's a debunk
I
for...
think he means debunking the evidence that is put forward, not the
no.
actual...
So
okay,
yeah.
gotcha.
Yeah.
Okay, all right.
Evidence refutation.
Gotcha.
Yeah, you're not debunking your own side.
Yeah, so you
right.
need... Yeah,
that doesn't even make sense. Right.
Yeah, one positive evidence for your side, and then one debunk of a claim from my side, basically.
Right, gotcha.
Yeah, that's...
No, you can go first, Craig. That's fine.
You want me to do my opening statement first?
Yeah, go ahead.
Okay, right. Bear with me because I'm just getting my notes up. Which I seem to have lost. Okay. All right, so tell me when my timer starts, Furball.
And go.
Okay, hi, I'm Fight the Flat Earth, owner of this channel and Bane of Stupidity. I regularly upload videos in my series Flerfs are Idiots, where I take a look at the people that say the Earth is a magic space frisbee created by some beardy bloke in the sky. Been debating for a while, and I'm going to take everything I've learned and been told about my debates, and I'm going to try and make this the best debate I've ever had. I'm an ex-Royal Navy nuclear engineer with 2 degrees, one in physics, one in nuclear engineering, energy systems and fission technology. Unfortunately, I'm disabled and I can't really get out and about much, but that has given me ample opportunity to fight the flat earth and find a new love of making videos and live streams for all the people that watch, and I can't believe that I've got 15,000 subs doing this. So thank you, everybody. I'm going to be arguing that the Earth is a globe that rotates at 15 degrees per hour and orbits the Sun, as modern science can clearly demonstrate these things to be a fact. I don't like the flat Earth. Frankly, I think it's ridiculous, makes no sense at all, and falls apart under even the tiniest of scrutinies. All you have to do is actually do some research and maybe learn a bit of basic maths and physics, and unless your understanding of the physical universe is fundamentally flawed, then I struggle to see how anyone can come to the conclusion that the Earth is flat. To believe that, you have to believe everybody is lying to you. All governments, scientists, pilots, ship captains, teachers, of course NASA and every other space agency, every satellite TV dish installer, and the countless men, women and children that accidentally discover the truth. R.I.P. Flat Feet Pete. Never forget. They're all lying, of course, and that's what I think is dangerous about Flat Earth, because if you believe the Earth is flat, then you have to believe that all other conspiracies are true, because everyone is lying to you. Like I've said, most people won't fall for it, but for the fact that some of the Flat Earth proponents are so charismatic and self-confident causes the vulnerable, less intelligent and paranoid people to get sucked in. I'm going to focus my argument on the movement of the Earth and show that the movement can only mean one thing, that it's a globe. There are countless proofs going back 2,500 years that the Earth is a globe. We've seen pictures from space like this one, which was the very first picture taken from space in 1946 and clearly shows there's some curvature. Okay, and I've lost my space now. It clearly shows there's curvature. Right, forget about the Earth. Never mind the Earth. We've managed to image the entire observable universe. We've imaged a black hole. As of mid-March, we've discovered 3,706 exoplanets, with a good percentage of them possibly habitable. We formed a united federation of planets and defeated the Dominion... No, wait, that was Star Trek. Sorry, never mind. Jokes aside, humans are striving to push the boundaries of our knowledge every day, and for some reason flat earthers want to drag science back to the Stone Age and do science experiments like making an egg float with salt water or pouring fucking water on a lava stone and proving evaporation is a thing, and somehow think this disproves our model. Flat earthers often talk about the holes in our model. Well, no, there isn't any, and until you can present any kind of model at all, don't criticize ours without understanding it. Honestly, flat earth is the most stupid thing I've heard in my 36 orbits of our nearest star, and I relinquish the rest of my time to the moderator.
All right. You had just under 2 minutes left, so JM, whenever you are ready.
Okay, so my name is Joshua Michael. I have a Bachelor of Arts and a Master's of Science degree in my Master's in Instructional Design Technology. I have been a flat earther for the last, well, since 2004, late 2014. And I was a huge proponent of the globe Earth. I went out to prove the Earth was not flat. We are not on a spinning disk spinning through space. That is not at all my understanding of the world that I live on, or the Earth, or the realm that I live on. As far as science, I've been doing experiments, well, most of my life, but the last 4 or 5 years have been an intense research study, as well as experiments, as well as doing a lot of different, well, experiments in different basic physics, and mathematics is not always the end-all be-all. I can manipulate math to say anything I want. Math, just because it works out, does not necessarily follow that that math is actually being presented correctly. Outside of that, I have a lot I will not be sharing tonight, as I will be sharing it on my film, my film documentary. But as far as that's concerned, let's get this show on the road.
Is that everything, JM?
Yep, that's it.
Okay, you had 3.5 minutes left. Craig, if you'd like to move into your presentations of evidence and debunk.
Okay, could you do me a favor? Let me know when I've got 10 minutes and 5 minutes remaining.
Yep.
Okay, right. Just
Same here.
when to start, and I'm ready to go.
All right, begin.
All right, so for my positive evidence, I'm going to give evidence that the Earth is in fact rotating. I'm going to give evidence of the Earth rotating in 3 parts, and I'm going to start with the Eötvös effect. I think that's how you say it. I literally looked up the pronunciation, but I've probably still got it wrong. So the Eötvös effect is a change in the perceived gravitational force caused by a change in your direction. So if you're going eastward or westward, you're going to have a different amount of centrifugal acceleration resulting from your velocity. So when moving eastbound, your angular velocity increases in addition to the Earth's rotation. That means the centrifugal force also increases, and that causes a perceived reduction in gravitational force, meaning that if you are traveling east, you will weigh more than when you're traveling west. In the 1900s, a team of German physicists tested this on boats in the Atlantic, the Indian and Pacific Oceans. And they did indeed note that the results were lower on boats traveling east. For the 21st century, it's much easier to perform tests like this. An Australian pilot and YouTuber called Wolfie6020 did his own experiments whilst traveling east and west. So he took this scale and weight, and this is, I'll put the link to the full videos. There's actually 3 videos. He took this scale and weight, and he weighed it before he got on the plane. As you can see, it's a 500 gram weight, and it weighs 500.00 grams at his particular latitude in Australia. So then on the eastbound flight, he weighed it during the flight, and it showed a reduction of over 4 grams in weight. Same scales, same weight, only difference is that he was traveling in an eastward direction. And then he did the same thing when he was traveling in a westward direction, and it showed that the same scale, the same weight, but there was an increase of over 2 grams. Not quite as much as going the other way, because the direction he was going wasn't completely perpendicular to the Earth's rotation, but it showed that even though he was going that direction, that made it that there was an increase. So this is repeatable by anyone. Verifiable. Anyone can do this. Just get a scale, take it onto a plane, and you can see that this happens. So that's my first evidence for the rotation of the Earth. My second evidence for the rotation of the Earth is the Coriolis effect. Don't worry, JM, I am not going to bring up the thing that I got very wrong before. So the Coriolis effect is basically to do with conservation of momentum. All right, imagine you are on the Earth in space. You're on a spinning ball, Earth. Why is it not merging? Sorry, it's not letting me. There we go. Right, so as flat earthers like to tell us, the Earth at the equator is spinning 1,000 miles an hour. So you have that angular velocity of going 1,000 miles an hour at the equator. Imagine you were able to just jump 1,000 miles south. As you jumped and started heading south, you still got that momentum of traveling 1,000 miles an hour. But as you head towards the pole, and go down the latitudes, the angular velocity is less and less. But as you maintain that 1,000 miles an hour, you would actually drift ahead of the rotation of the Earth until you landed, and then you had the same. So it's all about angular velocity and maintaining that momentum of the Earth spinning. We know that it's a thing because, well, the Army take it into account, and it's in the manuals for the US Army. And also an evidence for the Coriolis force is, where is it? A YouTuber called Gentleman Physicist set up a Foucault's pendulum in a block of flats near him. So the main thing I want to say about this is it's not all metal. There's no magnets moving it or anything. He just set up a Foucault's pendulum in this stairwell. And the reason he did this was because he wanted to see if he could figure out his latitude based on the drift of this pendulum. So from where he was, he left it for just under an hour, and there was a drift of 7.89. Using a bit of vector mathematics, then you could figure out actually what latitude he was. And I'll leave the link again to this in the description, and he got very, very close. And it all matches up with what we say should be true. So the Coriolis force is definitely a thing. Oh, sorry, my computer's running slow. It's definitely a thing, and there is a couple of evidences for it. Right. And my final evidence for the rotation of the Earth is a fiber optic gyro, or a ring laser. You know what? I'm just going to let Bob explain it.
If the Earth is spinning at one rotation every 24 hours, that means that every hour it has to turn 15 degrees. And if the gyroscope is mounted anywhere on Earth, it's going to drift. In today's 21st century navigation systems, they're using what's called a ring laser gyroscope. It is extremely precise. If we could simply get one of these ring laser gyroscopes, we would be able to prove once and for all that there is no rotation to the Earth. One of the people in the community actually purchased one for $20,000. But what we found is when we turned on that gyroscope, we found that we were picking up a drift, a 15 degree per hour drift.
Thanks, Bob. Great work. So a fiber optic gyro allows us to tell the Earth is rotating 15 degrees per hour thanks to something called the Sagnac effect. So let me put a little graphic on screen to illustrate the Sagnac effect. So in a fiber optic gyro, the ring laser gyro, the light goes in two paths, one clockwise, one counterclockwise. When the light combines afterwards, you can see if there's an interference in the wave pattern. And this will show that the gyro has been rotating as the light inside the gyro, for the path that's, because it's rotating, it makes one of the paths shorter so the light gets there quicker. And then it shows as an interference pattern. This is another graphic demonstrating as what happens. Obviously, at this point, it's not rotating. So the two light paths meet at the same time and they wouldn't show an interference pattern. But then if it is rotating, as in this next graphic, you see that one side goes quicker than the other because of the rotation. It literally makes the distance shorter. So when the light recombines at the other side, you can register an interference pattern, and this will literally show the rotation of whatever the gyro is attached to. So now Bob pointed out that his gyro that he got actually measures a rotation on 3 axes.
Just
so listen to what he
right
says.
Now, doing nothing, and if I zero it out, you can see it start, and these are the values that it's picking up. So it's not that it's picking up motion, because I can set up my mechanical gyro and it doesn't drift at all.
Nothing. Yeah.
But there is this ether, this luminiferous ether.
Okay, so he said that obviously his gyro was just sitting there, but it was picking up rotation in 3 axes. Now, that's exactly what it should do, because as Wolfie demonstrated here, when he took
We're going to register movement in all 3 axes.
He took a gyro off of one of his drones and put it on the model globe, and then attached it to his computer and showed as he moved the globe what rotation the gyro
drone is
should
rolling,
do.
pitching and yawing simultaneously. As I rotate the globe. We're going to register movement.
So, yeah, that basically shows that the gyro should register 3 axes of rotation. And if you left it for a year, you could even pick up the drift around the Earth, which is about a degree a day. The drift around the Sun, sorry, which is about 1 degree a day, because it maintains its fixed position relative to distant stars, and that's what makes it so accurate. So the rotation and everything that Bob's gyro was picking up correlates with what we should see on the Earth. Right, so that's my evidence for the fact the Earth is rotating, and the fact that it rotates, that it picks up that particular rotation, proves that we are on a globe that is rotating. So that's my evidence for the fact that the Earth is a globe and rotating. Now, as a counterclaim to a flat Earth, one thing that Bob was bringing up is that the luminiferous ether is what's causing the gyro to pick this up. And
you're at 10 minutes, Greg.
Okay, thank you. So, flat earthers say that the Mux and Morley experiment actually showed that the Earth wasn't rotating, when in actual fact it was really nothing to do with that. So the Mux and Morley experiment was set up under a very specific premise, and that is that because everyone knew that sound needed a medium to travel. And as we started to study light, we figured out that what its speed was, and that it behaves like a wave. And as sound is a wave and needs a medium to travel through, it was a safe assumption that light must need a medium to travel through. So physicists at the time made the assumption that space was permeated with this matter called luminiferous ether, which allowed the light to travel. So as technology increased and we managed to know what the speed of light was, it gave us the opportunity to test what the ether was doing. And now, in the same way as if you are in a car and you open the window and stick your hand out, you'll be able to feel the air rushing past because you're moving through the air. In the same way, Mux and Morley postulated that as the Earth rotates around the Sun, it would create an ether wind, which we would be able to detect. So what they did was they set up an interferometer, which I have a picture of here, on a rotating concrete slab. And they shined a coherent light source onto a mirror that was half coated with silver, which split the beam in two, bounced it off of 4 mirrors inside, and then recombined it the other side. Now, what they wanted to test for was to see if when they had the apparatus in line with the ether wind, against the ether wind, and perpendicular to the ether wind, they should pick up different measurements and register an interference, because the ether wind would affect the speed of light for what's going on. What they found was, well, they got a null result. On one of them, they were expecting around about 20%, but they got about 2% on one of them, which was basically down to experimental error. But it was a null result. They didn't detect any difference in the light, and therefore they disproved that the ether was a thing. Now, flat earthers always say that this is proof that the sky is moving and that the Earth is stationary. Well, to simply disprove that, I'd just like to show you page 2 of the actual paper and read this bit that I've underlined. And it says, if the apparatus be now rotated so that it is in direction of the orbital motion of the Earth, the difference will be in the opposite direction. They knew that the Earth was rotating around the Sun. They knew space was a thing. The only thing that they thought different to us now was that space had a medium called the luminiferous ether that was there to help light propagate. But we now know that light really doesn't need a medium to propagate. So no, the Mux and Morley experiment most certainly did not disprove the rotation of the Earth. It simply disproved that the aether was a thing, which then disproves Bob's assumption that the aether is causing the gyroscope to pick up that 15 degree per hour drift. Interesting side note, the LIGO detector that detected gravitational waves is basically a massive Mux and Morley experiment, and it's so big that it had to take the curvature of the Earth into account when constructing it. I've done a lot of research. I can go into more detail about the Mux and Morley experiment or any of the other evidence I have put forward in the open section of the debate, but for now I relinquish the rest of my time to the moderator.
All right, Craig, you had 6 minutes left.
Okay.
And for anybody out in the chat, if you have questions, specifically like what Craig was presenting, you didn't understand something, or if you got questions for later on in the open discussion, make sure you tag me in the side chat, and I'll try and copy over as many as we can so that we can address any issues anybody has. And try not to just focus on JM, because I can guarantee that the majority of the people in the side chat are probably on the Globe side. But we want to make sure that we test Craig's beliefs as well. So if you don't understand something that he's saying, ask the question.
And can I just ask that my mods don't just randomly time out flat earthers because they're disagreeing with what you say? I don't mind a bit of argument back and forth in the chat. Obviously, if someone is being horrible and there's reason to time them out, do that. But don't just time out the flat earthers for being flat earthers, please. I do appreciate my mods doing the jobs, but I want them to feel welcome in this stream.
Yeah, it doesn't look like that's happening so far.
Cool.
All right, JM, whenever you are ready.
Okay, let me set. I gotta do this through Hangout, so let me
Yeah, I'll just get that up for you, JM. If you just screen share what you want to present on Hangouts, and then I will put that up here for you.
Okay.
Oh, where did I put Hangouts? There.
Okay. It should be you, Craig. Do you see it?
No, just give me 1 second.
Yep, yep. You can have two.
I just want to quickly cut off the top of that. All right, go ahead.
Okay. So this is flat Earth versus round Earth scientific debate. All right, so I'm going to start with the basics here. What is science? Science is the knowledge and the study of the natural world based on facts learned through experiment and observation. You have to have both experiment and observation of the natural world. See it right there? Natural world. A particular area of scientific study, such as biology, physics, chemistry, and even biochemistry. A particular branch of science. What is a scientist? A scientist is a person engaging in a systematic activity to acquire knowledge that describes and predicts the natural world. Again, the natural world. In a more restrictive sense, a scientist may refer to somebody using the scientific method. The person may be an expert in one and or more scientific areas. Scientific method, the basic definition of a scientific method, a method of research in which a problem is identified, relevant data is gathered, hypothesis is formulated for this data, and a hypothesis is empirically tested. There is an example right there of the scientific method. Science versus pseudoscience. Science is physics, biology, chemistry, biochemistry, technology, and environmental sciences. All the sciences on the right cannot go through the scientific method. This is really not even arguable, but we'll see what happens. Cause and effect. The scientific method is actually a method to show cause and effect relationship of things in our natural world or in the earth. And I would say on the earth, because it doesn't matter whether it's natural. You can run a scientific study on technology as well. So anything that we can test it basically. Gravity is an effect. It is not a cause. Not a cause. Okay. In fact, George Mercer, Scientific American, November 1st, 2015. There are differences between both Newton's gravity and the gravity of Einstein. First of all, Newton's gravity is an invisible force. It's instantaneous action at a distance. It's Euclidean 3 space, which means neither Newton or Einsteinian gravity are not the same thing, as Einsteinian gravity is a different mathematical formula completely. Newton's gravity, no hypothesis or null hypothesis. Newton also never came up with any hypothesis or even null hypothesis for his gravity. Einstein's gravity was not a force. It is the bending of space-time, as we've all been told. Gravity is limited to the speed of light, which instantaneously disqualifies it because there's no null hypothesis and really no way to test it. It's also pseudo-Riemannian force space. These two things are not the same geometry, folks. So you've got to pick one or the other. You cannot have both. Now, I do believe in a force that holds things or that creates the density table. That's called electrostatic force, Coulomb's law, and I'll talk about that later on, but not here in this debate. The mass gravity hoax. Gravity is an effect, not a cause. Gravity is an effect for mass attracting mass, according to globe earthers. From Princeton, Martin Rees, fellow of the Royal Society.
JM, if I may
Yeah.
butt in for just a second, I've paused your time.
Yeah.
Remember that we've got
Okay.
10 minutes to provide positive evidence and negative evidence. So so far you haven't provided any positive evidence specifically for your beliefs. Is that gonna be in your presentation?
Yes.
Okay.
Yeah, it'll be
And
it.
now this is kind of debunking broadly, but do you have any specific debunks? Because I don't want you to run out of time, because the goal
What are you
here is
calling a
for you to
specific
say,
debunk? What are you calling a specific debunk? Because first that's at the end, right?
well, so far you haven't gone into any positive proofs for your belief yet.
Okay. Hey, so how much time does he have left, Furball?
He's at 16 minutes.
He has 16 minutes left. Okay, so JM, I guess what they're just
Correct.
trying to convey to you so that you understand, so you don't run out of time when you're trying to present evidence. He's saying even if this is part of your presentation, that's fine, but we just want to make sure that you don't run out of time while you're trying to provide positive evidence instead of just giving a general debunk of the other side or other people's beliefs. So that we're not at that point yet. So if you know you're going to get through your whole presentation in 16 minutes, then we'll just stay out of it and let you go. But if you kind of think you're going to be running short, why don't you skip the debunk part
I
for
should
the
be good.
end and focus on the positive. Okay, go ahead, Furball.
Yeah, bet.
All right, cool. All right, timer restarted. 16 minutes.
Okay. So a class asked Professor Rees, what causes gravity and mass? Is the universe infinite? How do these atoms assemble? Actually, I guess it's Martin Rees talking. On at least one planet around at least one. These questions have baffled us all. So obviously we don't have it all figured out yet. Rather than the end of science being nigh, we are still near the beginning of our cosmic quest. Ooh. According to Professor Rees, who was asked, does mass attracting mass cause gravity? No. So the Cavendish is not an experiment. An experiment has to be something of the natural world. Mass attracting mass, you cannot prove that. So Professor Rees even admits that here. According to Professor Rees, does space-time cause gravity? No. So apparently Professor Rees was either absent today to talk gravity at school, or he knows something we don't. Centrifugal force. I made the statement, I'll say it right here real quick, that centrifugal force was not a thing. Laughing with Dinosaurs did a wonderful little video about it. Centrifugal force is a thing. We have this issue between the two about what a force is. And so that's kind of where I was coming from. Okay, Coriolis, an effect whereby mass moving in a rotating system exerts a force, Coriolis force, acting perpendicular to the direction of motion and to the axis of rotation on the Earth. The effects tends to deflect moving objects to the right in the northern hemisphere and to the left in the southern hemisphere. Now, big question, does this affect planes and helicopters, which unfortunately fights the flat Earth? You had said multiple times that it doesn't. Apparently it does, because the answer is yes. Coriolis or should affect airplanes and other flying aircraft. So all those that say it don't, there's your debunk for that. Gas pressure. Now, here's my proof, folks. You all say there's an infinite vacuum of space. That cannot be possible. It defies the first and second law of thermodynamics, and we'll go into that. So the question here is, how do you have a gas pressure, also known as atmospheric pressure, without a container to begin with? The pressure of, let's look at the definitions here of gas pressure. The pressure of a gas is the force that gas exerts on the walls of the container. On the what? On the walls of the what container? And it must be a sealed container, not an open container. Okay? Also, the Boyle's law, observations about pressure may be explained using the following ideas: rapid motion and collision of molecules with the walls of the container cause pressure, force on a unit area. Pressure is proportional to the number of molecules collisions and the force of the collisions in the particular area. The more collisions of gas molecules with the walls, what walls? The walls of the container, the higher the pressure. When you pump up a tire, okay, the higher the pressure, or the more air you pump into the tire, the higher the pressure. It's pretty basic. Now, the fact that we have gas pressure here on Earth is a proof that we have to be living within a container, because you cannot have a gas pressure or a positive pressure, negative pressure in the same area. If I remove one of these conditions, collision of molecules or walls of the container, do I have a gas pressure? No. Pressure is proportional to the number of molecule collisions and the force of the collisions in the particular area. Gas pressure gradient is not an argument. What comes first? Gas pressure or gas pressure gradient? First, answer this question. How do you have a gas pressure without a container to begin with? Again, the second law of thermodynamics. High pressure systems, high temperature systems always flow into low temperature systems. If I take a hot coffee cup, set it on a table, it will dissipate until it becomes room temperature. Same thing with pressure systems. You will never get a low pressure system pushing its way into a high pressure system. It is not possible. You can have gradients, but those must be in a sealed container. Okay? Commonly, I will skip the fallacies. We don't need those anymore. I'll even skip all the documentation here, because everyone wants to explain away what they can't explain in the first place. So, well, we'll go back to this actually. This is FM 640, no rotation of Earth. Now, I'm open to the Coriolis, which is here on this one, but you have this chart that says no rotation and this chart that says rotation. My explanation is that they changed this chart because it doesn't even match the rotation of the Earth, even in mils, as far as how fast they say we're spinning versus how much you have to change the angle of attack for a mortar. Okay, NASA, International Space Station, facts or fiction? Gas pressure issue. The ISS is a positive pressure system and a negative pressure system. So we've been told that the vacuum of space is 10 to the negative 17 torr. Okay, NASA needs an 8-foot steel reinforced wall to create that vacuum. NASA is lying about being up there in the first place. There is no place to disperse the heat that the ISS is taking in from the sunlight. We see on the space station they have those these panels here. Okay, those panels are absorbing light and absorbing heat. Globe Earthers cannot have it both ways. You say that there's negative space or the vacuum of space has no molecules in it, but that seems like a pretty big molecule right there. If you're understanding my take on it, you have lots and lots of molecules all condensed into one area. That spacecraft, alleged spacecraft, should be taking on heat at all times it is in the sun. Well, it's got to dissipate heat somewhere, and it has nowhere to go because there's absolutely no molecules in space for them to get rid of that heat. The thermosphere ranges between 500 and 2,240 Celsius, which is 932 to 440 Fahrenheit. I've yet to hear anyone actually argue this fact, because this one defies all physics completely to even say the space station's even up there. Here are lead, magnesium, aluminum, alloy. Now, I took this directly off the NASA website as far as what their space station is made of. These are all of the main elements that station is made of. Here are the melting degrees, okay? Now, you have, again, the space station would have to heat up when light hits it. They are molecules, ladies and gentlemen. That is the basic law of thermodynamics and the basic law of physics. Okay, it is impossible for this space station to survive these temperatures. Plastic melts at like 100 and some degrees. It's ridiculous. There's nowhere to diffuse this heat. Like I said before, the astronauts would bake like in an oven in this space station. How many more minutes do I have left?
You are at 8 minutes. And just so you know, here, I'll pause for a second. Like we'd mentioned before, we're trying to go after specific proofs and debunks, because following this is going to be the rebuttal from the other side. And at this point, Craig has about 30 different things he can try and respond to. So I would suggest in this last 8 minutes, focus on your strongest proofs to give him something to respond to. That way he's not, doesn't have one sentence to describe each thing that you talked about.
Gotcha, okay. I will skip through all the rest of this. Okay.
And whenever you're ready, I'll hit go.
All right. All right, proofs. Horizon always appears at eye level. Water doesn't curve. Pressure is actually a proof. If in fact the space was infinite, like we've been told, Older's paradox should be a thing, which means the whole night sky should be a solid light from all the stars in it. Planes do not correct for curvature. I've got a bunch of pilots that are all going to explain this in my film, so I'm not going to cover it too much here. The Nile River flows for thousands of miles with a fall of only 1 foot. Parts of the West African Congo. Yeah.
Like I said, you're just kind of throwing a bunch of stuff on this. I want you to focus on something that Craig can actually rebut with his own knowledge and intellect.
I've given him a ton.
That's kind of the goal here. So that, yeah, but you've given him like 20 different things.
Well, he can pick one. He doesn't have to go after all.
I get what. Okay. What I guess.
I guess what I'm asking is you guys apparently have
the Flat Earth gave you 3. Well, hold on. He gave you 3 very particular proofs of his side, and that's what he was giving to you to focus on. What you're giving him is 20 plus proofs of your side. Now that's fine. You can do that, but it's going to be hard for him to refute all 20 of them. So what we're just asking is, can you pick 3 of them that you are going to say this is definitive proof of a flat Earth, or definitive?
Okay.
How about this, JM? Yeah.
Okay.
How about this,
he
JM?
can
So once we
particular points.
Yeah. Once we move into the rebuttal portion, I'm going to ask you to pick your top 3 that you provided evidence for, and those are going to be the ones that he's going to focus on.
Right, gotcha.
Because otherwise he's going to spend 20 minutes just trying to figure out what to focus on. And that doesn't really solve any problems, because it doesn't give him a chance to actually address anything you said.
No, I understand what you're saying.
Okay?
You want me just to pick 3?
All right, you have 7.5 minutes. Yeah. Yeah, that'll be the best for him to actually be able to rebut something, so he can kind of stick to the format a bit.
Okay. So gas pressure.
What do you have left? What do you have left in your presentation? I mean, do you have something in the rest of your presentation? Do you want to finish this and then we'll pick something?
I've got a huge presentation, so I'm not going to get through all this anyway. So.
Okay.
This is a
how do you want to handle this? And you have 7.5 minutes left.
I'll just give him 3.
Your 7.5 minutes.
Yeah, gas pressure. Water always finds its level. Of course, I know his argument's going to be level doesn't mean flat. So,
yeah.
And then the curvature.
Provide your evidence for those so that he's got something to talk about. Okay.
Oh, okay.
Because just so you understand, if your evidence is water always finds its level, that's not you providing evidence. That's you providing a statement and a belief. That doesn't he can rebut that, but he needs to rebut your position on it. And the one sentence of water always finding its level doesn't give your position on it and your evidence to support it.
It feels like you guys are making this way harder than it needs to be, but
well, we're trying to have a back and forth so that you guys can discuss specific topics. Yeah. So it's not a gift gallop.
So it's similar to me saying like this, okay? I could say, oh, the globe proof is things disappear from the bottom up. Now, you can refute that, but I've not presented any evidence to support that statement. That's what he's saying. Like, to make the statement, water seeks its own level or finds its own level, is just a statement of declaration, not backed by any evidence whatsoever coming from you. There might be evidence out there, but you're not presenting that evidence. You're just making the assertion. We're saying, is there anything that you do have evidence for that you can not just make the assertion, but also explain why you believe this assertion to be true?
Okay, this is a picture, 3 pictures in fact, of horizon at different levels. That's a proof. That's a visual proof. No?
Can you walk us through this then? I'll start your time back up. Walk us through this and why you believe this is one of your proofs.
Okay. The first picture is a picture at ground level. In fact, the first 3 pictures are almost at ground level. The last half of the pictures here are at, well, as high as we can get any kind of a balloon to go, upwards of 120,000 feet, I believe is what, 20 miles high. I guess it's right there on the sheet. Okay, and the horizon is still level. The red line represents a level created in a computer, a straight line in a computer, okay, which matches that horizon. I think I've made things really, really clear. I'm not sure.
Okay, so that's one. Now, what's the next one?
What are you saying? What's the next one? This right here.
No. That's okay. No, hold on. What I'm saying is there's one right there. We're trying to get you to give 3, so he has 3 specific evidences that he can refute. That was one. That's a statement backed up by some sort of evidence to say that why, giving us a reason to believe why you're asserting this. Okay, so and he'll refute that in a moment. So now the next one, now number 2, and we'll give you a third one also, and we won't even worry about time because we'll just say that whole first part was just, that was icing, that was our appetizer. Now we're eating the meal. You've already given us the first part of the meal. It's a 3-course meal. Second part, go.
8 inches times mile squared.
That's your assertive statement. Now back that up with evidence.
Yep. Talk to us about that.
No. You have to back it up. There is no measurement of that. FE Core just did a level. Hold on.
Let me hold on. Let me speak real quick.
This is what you guys
fight the flat Earth. Hold on.
I don't know what I'm doing.
JM, listen. Fight the flat Earth. Fight the flat Earth. Listen. Fight the flat Earth will refute that point. You said 8 inches per mile squared. Now give something to back that statement up. That's all we're asking for. We're not asking for just one statement. We're just saying back that statement up now with some kind of evidence.
If you give me a second, I will. I was in the process of doing that.
You got all the time in the world. You got all the time in the world.
FE Core just did an experiment, okay, in Colorado, where all of their data is actually on, I believe, online for people. There is no curvature whatsoever, no curvature or concavity.
Okay. Hey, JM, before you go into your belief on the debunk side, I would like you to explain your view of the globe side of that statement. Why is that an argument for us? What is the premise that you're talking about?
Well, because if Earth is a globe, it should be measurable. I should be able to go out and at 8 inches times mile squared, I should be able to do an experiment. I should be able to run a laser across the lake. And at 8 inches times mile squared, I should not be able to hit the other side of that lake.
And
because there's 66
scientific backing of what is the scientific backing on our side of it where 8 inches per mile squared comes from? Where is that used? How is it used? Who developed it?
And 8 inches
where
per mile
you're
squared
saying
is
our side is wrong.
Formula for a parabola. A parabola is the way you measure a curve.
Okay. Do you know any industries that formulation? Where did it come from? Again, giving Craig more to rebut against, or to discuss, I should say.
It's an industry standard. See, this, you guys, this is 8 inches times mile squared has been an industry standard for well over 50, 60 years, if more, not more. Just because NASA removed it from the website.
That's what I'm asking. I'm asking you to provide that basis for what you're discussing. So it's an industry standard, 8 inches per mile squared. Is there anything else you would like to talk about that can give Craig talking points when he talks back? Or we can move on to your next strongest proof that you believe.
So, huh?
Okay.
It's not
then
even
what
a
is
belief.
your next strongest
I'm
proof?
providing evidence.
Okay.
I don't have any belief here.
So we've got the horizon always raises to eye level, curvature 8 inches per mile squared. What is your next strongest belief that you don't think that Craig can try and shoot down?
Gas pressure.
Okay, you'd started
I
that.
just
Did we
read you
get
the
through that
definition of
entire
gas pressure.
presentation?
What's that?
Okay. I know you'd started that presentation. Did you get through the end of it before we started talking?
Oh, yeah. I mean, did I get to the end of it? Not my full presentation because it's not on here, but I gave him enough that he should be able to have enough to go on. Yeah.
If you wouldn't mind, go through presenting the gas pressure again.
Okay. Okay, where are we here? Go back and find it here. Come on. Okay. Question is, how do you have a gas pressure, also known as atmospheric pressure, without a container to begin with? The pressure of a gas is the force that gas exerts on the walls of the container. Therefore, it must be a sealed container. Sealed container. Kinetic molecular theory, explanation of Boyle's law, observations about pressure may be explained using the following ideas. The rapid motion and collision of molecules with the walls of the container causes pressure. Definition is force on a unit area. Pressure is proportional to the number of molecular collisions and the force of the collisions in the particular area. The more collisions of gas molecules with the walls of the container, the higher the pressure. If I remove one of these conditions, either the collision of molecules or the walls of the container, do I have a gas pressure? Hell no. Pressure is proportional to the number of molecules, of the number of molecular collisions, and the force of those collisions in the particular area, which is the definition of the type of the level of pressure. Gas pressure gradient is not an argument. What comes first, gas pressure or gas pressure gradient? Again, first answer the question. How do you have a gas pressure without a container to begin with? Because I hear people all the time saying gas pressure gradient, gas pressure gradient. You cannot have a gas pressure without, or a gas pressure gradient without a sealed container. You can have a gradient within a container. An example of that would be a paint can or even a propane tank. Okay, they've even done experiments showing hot and cold ends of a propane tank, and you can have really cold on one end and really hot on the other. You obviously have a gradient because the molecules are bouncing around at different rates inside that container. So the second law of thermodynamics, high pressure systems always flow into low pressure systems without fail. That's a natural law. Okay, therefore, my assertion is there is no such thing as the vacuum of space. The only pictures you've ever seen are pictures from NASA and other government agencies. As a filmmaker and graphic artist, I can tell you that I myself have taken these films and these pictures, and they're all composite images and computer generated images. With that, I will yield back my time.
Okay. So at this point, we move into the rebuttal phase, and if you guys won't, if you'll agree, I think that to maintain fairness, I don't want Craig to rebut your points right now, being that you just finished, and that gives him an unfair advantage. Are you okay continuing talking, rebutting Craig's previous points as long as he restates them?
Sure.
Are you good with that, Craig?
Yeah, cool. I'll just briefly go back over what I'd said. Right, so I gave three evidence for the rotation of the Earth. One being the Eötvös effect, one being the Coriolis effect, and one being the Sagnacki effect shown within fiber optic and ring laser gyros. Thank you, Bob. Obviously, I showed the evidence from Wolfie with the Eötvös effect, repeatable test anyone can do. I stated my reasons for thinking that the Coriolis force is a
Greg,
thing.
Greg, go back to the Wolfie. I'm sorry,
Yeah.
but go back to the Wolfie one. I'm
Yeah.
not sure I understood which one
Right.
is that.
So that was when he took the weight on the plane. This is it beforehand. This is it traveling east. And then this is it traveling west, showing that a change in centrifugal acceleration based on your direction of travel will cause a change in the perceived gravitational force, making the weight different depending on which way you're traveling. So, and then for the Coriolis force, I pointed out that it's to do with conservation of momentum. And I showed the Foucault pendulum experiment done in the block of flats, where he managed to calculate his latitude based on the amount of drift done. And then for the ring laser gyro, I showed Bob's experiment and then explained the Sagnac effect. And then I explained what the Mux and Morley experiment was and why it didn't disprove the rotation of the Earth.
So your entire presentation is rotation, correct?
Yeah, and the fact that the three axes of rotation shown from a fiber optic gyro show that we are on a globe.
And what was your rebuttal point?
The flat earthers say the Mux and Morley experiment disproved rotation of the Earth, when in fact, all it did was disprove the aether.
Okay. Whenever you are ready, JM.
Okay.
I'll keep myself muted.
Sorry, this is the problem with having a huge presentation like this. Okay. Okay. So whenever I'm ready.
Yep, whenever you're ready, begin.
Okay, I'm only going to cover a couple of these things because some of them, to me, are just not worth even addressing. But I will try to address as much as Craig put out on a broad scale. But
Okay.
so my biggest issue is one of the things Craig said was about being able to take up these stars and things from millions of miles away, and yet I can't take a picture 2 miles away and or get a clear picture or even a clear phone message without having direct line of sight. So to me, scientifically, again, all the pictures that you can look at as far as NASA are concerned are not real. I would consider myself an expert on that.
Was that one of Craig's proofs, though?
I only supposed to be debunking the proofs that he presented? Is that what you guys are doing here?
Yeah, that's what we're trying to do, so that you guys can have a back and forth on specifics. So this is your chance to rebut what he presented.
Okay. The Foucault pendulum does not prove the rotation of the Earth. Okay? Please give me some kind of a proof that it proves any kind of rotation whatsoever, because the numbers you gave me are not even 15 degrees, and 15 degrees is what we say that, according to Bob's, gyro, they picked up. Stop motion photography, as your demonstration was cute, by the way. Bob, however, did not have a gyro in his possession when he made the comment that everybody wants to slam him for and say, well, he proved the Earth is spinning. No, he didn't. He said the gyro picked up 15 degrees of motion. That does not necessarily mean that the 15 degrees of motion was the Earth spinning. It could have also been picking up the ether spinning. So really, you guys really need to stop using that video as your proof, because Bob even admits he wasn't there for that experiment. He didn't have that gyro in his possession when he made the comment from behind the curve. So, in fact, I'm going to tear down behind the curve pretty good in my documentary. So you know, it's not a good example to use that laser gyro. It also is probably not advisable to use it if you've never touched it and understand what the three access points are on that gyro and understand what it's picking up. Okay, again, it's another assumption to assume that picking up 15 degrees that it must be the Earth spinning. Okay, you have never, again, like I said, you've never touched the laser gyro, but you want to explain what other people are doing and take snippets of what people say out of context, and then slam someone like me because I cherry pick, so to speak. That to me is not even a proof at all. It's taking things out of context. The weight experiment that you showed does not necessarily, again, prove. One, it doesn't prove gravity. It just proves there's a weight on a measuring plate. Okay, it doesn't prove. Weight is affected not only by the object itself, but all the molecules that are stacked on top of it. Well, depending on how high the atmosphere goes, you're also weighing the object and all the molecules that are directly above that object. If, in fact, gravity, or even if there's even a force, because all those molecules are still stacked on top of an object. So what that experiment that you showed measured is beyond me, because it doesn't show gravity. Gravity has never been established. These are things that we've talked about for a long time. So I don't see anything here worth debunking other than the laser gyro that you don't seem to understand what that experiment was, and you're misquoting Bob well out of context. So with that, that's what I've got.
So you talked about the pendulum, you talked about the weights. Do you have anything you want to say about Coriolis?
Again, Coriolis either is a thing or it's not a thing. If it's tethered to the Earth, then it's not a thing, because the whole definition of Coriolis is the atmosphere rotating opposite or in contradictory to the rotation of the Earth, which is what causes Coriolis in the first place. So, again, there is no Coriolis. That's kind of a ridiculous statement. Planes would have to land at ridiculous angles in order to even compensate for Coriolis. You could take a plane off and wait for the Earth to come back around, do a big loop, and come back around to the same place you started and land that plane. That doesn't happen. So, not only is Coriolis not real, the rotation of the Earth isn't real either. But yeah.
Okay. Do you have anything else that you want to address to Craig for his points?
Nope.
Craig, did he miss any of your points?
No, I suppose he skated the surface of them.
Okay. All right. So
Can we
then
stop
we
the
will
time?
yield the rest
Can
of
we
the time
stop the
back.
time?
Yeah, your time
Can we
stopped.
pause
Don't worry.
the time for a second? I
Yeah.
Since I have the forum, I'm doing this between the two sides. What exactly to you guys is a proof? Because apparently we don't have the same definition of what a proof is either. Because all I keep hearing is, well, you didn't provide proof. You didn't provide proof. And I've been laying down proof for months and months and months, and nothing that I'm laying down and other people laying down is accepted. And I understand this is the problem with the belief system we have. So I've just given you 20 freaking proofs.
Yeah.
And
All
we do is
I'll
skate
let Craig
around and
address.
explain away those things. So
I'll let Craig address what he feels as a proof. For debate format, you need to present those proofs. If you've discussed it in a video prior, that's not this forum. The purpose of the debate is for you to present your proofs in a manner that the audience can understand it, can grasp what you're saying, and as a basis for your beliefs, to give the other party the opportunity to discuss the proofs you've presented. So that was the format we're aiming at here, is for
with
you to present
and definitions, and I got stopped multiple times saying I'm not providing whatever you guys were looking for. So that's
well, a lot of the proofs you were presenting were single one-liners, and we were trying to get there. We wanted more meat. That's what we were looking for, is more meat for your position. That's what we were going for. So, Craig, I would say, discuss what you view as a proof is before we move on.
Something that can be backed up with not only repeatable experimentation, but a mathematical representation of it, and matches the laws of physics as we understand. That's why I presented particular experiments that were backing up the points that I was saying very specifically. I mean, you guys were saying to JM about his 3 strongest proofs, but frankly, just give me 20 minutes and I'll just debunk everything he said.
Okay. So, JM, before we move on to Craig's side,
the law of physics as you know it, but we obviously have a different definition of physics. So that's my biggest point of contention.
Well, maybe someday we'll have a debate on what exactly the laws of physics are and your beliefs behind them. So, for a future date. So, before Craig moves into his rebuttal time frame, JM, if you could take a minute or two and just briefly readdress your positions. You discussed horizon always finds eye level, curvature, and gas pressure.
And gas pressure.
Is there anything specific you want to talk about those for just 30 seconds to give him a reminder of what he's rebutting?
Yeah. The law of perspective is always that, the horizon's always at eye level. It doesn't matter whether you're at the sea level or whether you're 120,000 feet up. We have pictures, ranges proving that. And I don't care about a few millimeters down, a few millimeters up, whatever. If we're on a ball, the physics should operate much, much differently than the way it does. It operates as a flat plane. That's what it apparently is, because that's what most of the laser tests and all the other tests that we've done show it as. As far as gas pressure is concerned, that's pretty self-explanatory. I've kind of nailed that one to the ground. So the curvature is concerned, I have yet to see one proof of curvature.
Okay.
Mathematical proof
Craig,
of curvature that actually works in the physical world.
Oh, okay.
Okay. Whenever you're ready, Craig.
Right, so let's start with what you said about gravity being an effect, not a cause. You really don't understand what we mean when we say gravity. The fact is, we don't know everything about gravity. We don't know the exact reasons why it happens. And this is things that Newton never actually talked about. Newton didn't want the apparent magical properties of his understanding of gravity to be ascribed to him, because he knew that couldn't be a thing. Newton's law of gravitational attraction basically acts as if gravity is instantaneous, as if magically reaching out and holding the moon in place. But that doesn't mean that Newton's law of gravity in a local environment is not an extremely good approximation and is actually a thing that works and is used every day in engineering all around the world. When Einstein came along, he tried to expand upon Newton's understanding and gave that equation, because Newton never really had a theory of gravity. He just said, right, well, I can see that that drops like that and this matches this equation, so here's the maths that matches what I'm seeing. And then Einstein came along and he gave that a reason. He ascribed it to the warping of space-time by a mass, which changes the locality of things, which manifests as an acceleration in physics that we can measure. It is an apparent force, the same way that centrifugal force is an apparent force. Now, I very specifically said to George Musser, does he agree with my assessment of gravity? And he said, yeah, that's pretty good, and then went on to explain why. So that's basically how we feel about gravity. We don't know the exact 100% causes of it. We know that near a black hole, even Einstein's equations seem to break apart. We've been working towards a unifying theory of gravity for a long time. No one ever says we have a complete understanding. All right, Coulomb's law being the same as gravity. No, just no. Just because they share an inverse square law behavior doesn't mean they're the same thing at all. Coulomb's law was actually first introduced 78 years after Newton's law of gravitational attraction, and the main thing about Coulomb's law, which is completely different because it actually describes an attractive and a repulsive force, whereas gravity, Newton's law of gravity, simply describes an attractive force. They are not comparable. The only thing they share is an inverse square law function, and that's it. Right. Professor Rees, what you were saying about what he says, yes, he's right. We don't know exactly what gravity is. It's not caused by mass attracting mass. That is just one of the effects of whatever gravity is that we can measure. And when the Cavendish experiment was done, that was proof of the fact that mass attracts mass. This has been backed up by the Shishelian experiment, done again recently by people in Scotland, where a plumb bob on a mountain in Scotland is actually attracted towards the mass of the mountain. Everything you said about what Professor Rees is true, but it simply comes down to flat earthers' misunderstanding of what our understanding of gravity is. Gas pressure, you just constantly go on gas pressure, no container, no container. The fact is, gravity is the container. Gravity is the thing that is keeping the atmosphere here. And yes, I can cite the gradient as an evidence, because if we are in an enclosed system, then there's no reason that gradient is there. More importantly, you keep saying we can't have gas pressure, we can't have that gradient without a container. Well, okay, well, why does the pressure in the ocean increase with depth? Because there's no container on top of the ocean, according to you. So, yeah. Right. Negative Tor. What you said, 10 to the negative 17 Tor. That, I think we've discussed that that's not a negative number. It's just a very, 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 very small number. Tor is simply a absolute measure of vacuum. 0 Tor is the lowest you can get. You cannot have negative pressure. That is not a thing. So the
Never said negative pressure.
So Tor. When you're saying about NASA has to have these steel chambers to create the final bit of the vacuum, that's actually completely false information. The big steel concrete chamber you're talking about was actually to block out radiation from something else. The fact about a vacuum is that you can't have a vacuum on Earth that is stronger than 14.7 psi, because a vacuum is based on the atmosphere pushing down into the space created. So this is evidenced by the fact that there was an experiment done with trying to suck water up a straw several stories. It could only go a certain distance, even with a vacuum pump on the end, because there simply isn't enough pressure in the atmosphere to push the fluid all the way up that straw. Frankly, it's a fundamental misunderstanding of what pressure is from you guys, and just outright denying that gravity is the container that we need for this to be a thing. Right, heat issues. The ISS is in space. You're saying it's going for all these temperatures in the thermosphere, blah, blah, blah. Well, you might be right about the temperatures of the individual molecules, but there's so few of those molecules there isn't anything to transfer the heat energy to the ISS, which is why it is not melting. There's a difference between radiative heat and the way that heat is put through space. Yes, you can have like infrared, which is transferring heat through space, but you don't get like burnt from just the heat of the sun by being up there. When you were talking about the solar panels on the ISS, they just convert the energy from the waves of light into electricity. They don't accumulate heat. I was a little confused as to why you were saying that. I think that's a misunderstanding of how solar panels work. So yeah, the thermosphere, like I said, it's just there isn't enough material up there to transfer the heat energy to the ISS. We know that the ISS is at the height that it is, that we say it is, and the speed that it's going to, thanks to Red's rhetoric and Astronomy Live. Horizon always at eye level. No, just no. No, just no. No, just no. Did I say no? Because no. Water doesn't curve. Well, I mean, I guess I thoroughly disagree with that because we've shown it curving so many times. Bear with me just 1 second. I'll get a video to show. Okay. Sorry, just bear with me 1 sec. Okay, right, I'm just going to play a quick video to show that there most certainly is some curve. Sorry, my computer is running slow. I'm just getting it up. View up there. So I'm just gonna. All right, you say there's no curve, then please watch this. Yeah, there is curve, lots of curve. And just to cover the 8 inches per mile squared thing, you're right, it's a parabola, which is a curve, not a circle. A single function in maths, 8 inches per mile squared, cannot curve back in itself. You need 2 functions for that to happen. Say, the radius of the Earth, the actual distance away from the Earth that parabola curve would be is 3 times the radius of the Earth. So 8 inches per mile squared is a good approximation for less than 100 miles, but is certainly not something that any globe earther or NASA would ever say as the curvature of the Earth, because that simply isn't true. The first time 8 inches per mile squared was brought up in this whole argument was by the OG Flerf, Samuel Rowbotham, when he misread it under the heading leveling in the Encyclopedia Britannica. I think I've covered everything that you said. I mean, we can talk about your rebuttals to my stuff in the back and forth bit, but yeah, I relinquish the rest of my time to the moderator.
And I'm back, guys. Just didn't want to interrupt.
Oh, BM, are you muted again?
Damn it. Ring the bell.
Ding.
So you had 10 minutes left, Craig. So good timing.
good.
JM, it looked like you had some thoughts on Craig's rebuttal, so I will give you the floor. So right now
All right,
we are at the back and forth. We got 45 minutes, but this can kind of go as long as Craig feels is appropriate for his channel. And then I've also got a handful of questions for both. And if anybody else has more questions, please tag me in the side chat, and I'll try and pull them over as long as they are pertinent to the discussions at hand.
Yeah, my first comment would be I love it how I got to hand it to you guys. How it appears from my perspective, globe earthers like to skate around things or try to pull things together and make pumpkin pie out of freaking cherries. I just don't get it. Newton's gravity and Einstein's gravity are not the same force. Let's start there. Einstein said they're not. Let me finish. Einstein said they're not the same force. Okay? Do you not understand this? What experiment?
So can I have citation for that? Einstein said that they're not the same force. I'd really like to know where that came
They
from.
were in the presentation I gave you, dude.
Could you show me where Einstein said it's not the same force? Because the thing about Newton's law of gravitational attraction is it can be derived from Einstein's field equations. So how is that possible if they're not the same thing? Because math is what they are. Now,
Craig, Einstein, hold on. Einstein was debunking Newton. That's where this whole thing came from. You guys never want to address that.
Okay.
Einstein was debunking Newton.
Right. Einstein wasn't debunking Newton. He was expanding on his work. And this is evidenced in the fact that this is evidenced by the fact that he actually said these words. He said Newton's law of gravitational attraction can never be undone as one of the most important foundations of physics, or something along those lines. I'm paraphrasing. But Einstein knew that Newton was wrong with a lot of things because, yes, he was wrong with a lot of things. Because, let me finish my point, all right? Einstein knew Newton...
You realize you stepped in on top of me, right?
Well, no, I'm responding to what you said about Einstein and Newton not being the same thing, all right? Einstein knew that Newton was wrong about a lot of things because, like I said, Newton's equations work as if by magic because they don't take into account the things like the speed of light, relativistic effects. But Einstein managed to figure out that gravity was limited by the speed of light, and that's why he developed his theories around what it was. Yes, Newton was wrong with a lot of what he said because he didn't know about space-time. He didn't know about the speed of light. But his law of gravitational attraction is a functional mathematical equation that accurately represents the universe around us. And again, can be derived from Einstein's field equations. They do represent the same thing. They explain it in a different way. If you want, Newton was the what, this is what's going on, and Einstein was the here is how it's happening. They both were the same thing, and Einstein talked quite a lot about how Newton was the basis of of physics.
Can I finish my?
Yeah, go ahead. Yep, your floor is yours. We won't interrupt.
What experiment did you do to prove bendy spacetime? I'd love to see it.
Okay, I've never.
Is not. I know. That's my point, Craig. Cavendish is not an experiment. There's no natural phenomenon associated with the Cavendish so-called experiment. It's not even an experiment. It's a really cool show. Again, there's no natural phenomenon you can point to.
Okay, there
except
is.
for the sky, which is not a natural phenomenon.
If I may interject here for a second, JM, are you asserting that? Because this is a common belief: is if you haven't done it, it's not true, or are you asserting that the experiment itself is flawed because it's not natural?
Well, I'm sure he hasn't done it, but I'll forgo that one and just go with the latter. Forget whether he's done an experiment at this point. The point is, the whole thing is flawed.
Right. So yes, there is a natural phenomenon in the Cavendish experiment of mass attracting mass. Doesn't have to just be done with lead weights. It can be done with anything, pretty much.
No. Your natural observation, Craig, is something we observe in nature.
And we observe mass attracting mass every time something accelerates towards the ground.
No, that is not proof of that. You cannot.
I didn't
assert
say
that.
it was proof. I said it was a natural observation. Let me explain. I observe that when I let something go, it's attracted towards the ground. Okay. Now
Okay.
I want to test.
Holmes law also can prove that.
Wait. I want to test if this attraction is just up and down or also on a vertical plane, and that using the Cavendish we can do that. But not talking about. Do you know what the Shishelian experiment is? Have you ever heard of that?
The what?
The Shishelian, I'm probably saying it wrong. The Shishelian experiment. It was done on a mountain in
No.
Scotland, using a plumb bob hanging off of the Shishelian mountain in Scotland. They were able to basically weigh the world by knowing the approximate composition of the mountain they were on, and they could see how much the plumb bob was attracted towards the mountain, and based on that attraction they actually were able to calculate the weight of the Earth the same way Cavendish was able to, and they got to within 10% of the current values. This experiment has been repeated in modern times, and there was a good BBC documentary on it, and that is another evidence that mass attracts mass, and there's nothing to do with lead attracting lead. It is evidence that there is something making mass attract towards mass.
I would agree that there's something causing things to fall to Earth. Absolutely. Gravity has not been proven. Gravity is not, there's no experiment that's ever proven gravity. However, Coulomb's law absolutely could be a reason why things fall to the Earth and why it's directional.
I mean, I have to thoroughly disagree with that, because Coulomb's law, as I explained, is a attractive and repulsive force and is based around electromagnetism, and that would mean that
But everything is electromagnetic.
yeah,
Craig.
but for that to be the reason of things accelerating towards the ground, and the fact that everything has a constant acceleration, we would have to say that electromagnetism affects everything equally. It doesn't repulse anything. It doesn't have more of an attraction to metal.
Electromagnetism has both positive
I'm
and
going to
negative.
ask that you don't talk over me when I'm trying to make a point, JM. My point is that Coulomb's law cannot account for the constant acceleration of everything towards the Earth, because it would have to take into account the different materials when you're talking about electromagnetism, and it doesn't. And it's an attractive and repulsive force. You cannot use Coulomb's law to calculate the acceleration of things towards the ground. You just can't. It's not. It doesn't suit that purpose. The equation, unless you can show me some maths to tell me how. Wait. Let me finish my point. Right. If you can show me using Coulomb's law why a 1 kilogram block of something accelerates towards the ground, I would love to see it. But Coulomb's law cannot explain that. It doesn't have that function.
JM, before you respond to that, could you please describe what Coulomb's law is? And then rebut what Craig just said.
Coulomb's law is the mathematical equation of electrostatic force. It's the mathematical equation we use for calculating forces, electrostatic force between objects. So actually, it does exactly what Craig said it doesn't do. And no, I'm not prepared to do a full explanation of that right now.
Okay, my point,
Craig,
my point is that
for quick.
Sorry. Yeah, quick.
Yeah,
my point is
there
that
anything with what he said incorrect?
Yeah, the equation
Is there anything
simply,
that he just said about Coulomb's law?
Yeah, the equation simply isn't fit for that purpose. You simply cannot calculate why things accelerate towards the ground with Coulomb's law.
Craig, you cannot say it's not good for that purpose unless you can prove it. Otherwise, you need to stop that argument. Wait, let me finish. Otherwise, my advice to you would be to stop that argument right now, because you saying it is some way is like me saying it is some way. It's your word against mine. Unless you're prepared to demonstrate how that mathematical equation cannot do that.
But JM, actually, that's the backwards for burden of proof. You are claiming that Coulomb's law is an explanation for why things accelerate towards the ground. Therefore, you would have to present the evidence for that, because I can do the math and show you that it's nothing to do with why things accelerate towards the ground. However, with Newton's law of gravitational attraction, I can calculate exactly the speed that things should be falling towards the ground based on their weight. Exactly. 100%. It's never wrong. Not ever, ever wrong unless you go beyond kind of a local system. For purposes on Earth, calculating the force down, Newton's gravitational law of attraction is right every single time. Coulomb's law, the equation itself is simply not fit for that purpose.
That universal gravity was not created until after Coulomb's law. You can
That's
look
wrong.
that up.
No, it's 78
No,
years.
it's not.
Yeah, actually, it was 78 years
not.
after.
I just did the research on this, Craig. It's not.
Right. Okay, what date was Coulomb's law first introduced? It was 78 years. I'm telling you right now, it's 78 years after Newton's gravitational law of attraction.
No, they took the date that Newton came up with gravity and they attached it to Coulomb's to.
Oh, right. So
universal gravity.
everyone's faking it. Right. No. So here's the thing. Coulomb's law was first
Let
introduced.
JM talk about his evidence of where it was introduced and his backing.
Okay.
Thank you. Find it. I have it in my archive somewhere, but that's like digging through cow shit.
All right, Craig, if you have the information pulled up from your research, go ahead for it, and then we'll let JM once he's found his.
Published. Okay. Event sensitive average to measure electrical. Okay. Coulomb first published his findings 785 to 89. Oh, I did have the pages bookmarked, but I've lost my folder.
All right, maybe that's for a conversation for another time, since apparently we're not going to agree on this. I do have some questions, though.
Wait,
Yeah,
I do. Where is it? So Newton first published his law. Where's the bloody date? Newton first published his law 5th of July 1687. And Coulomb's law was first introduced when he invented sensitive apparatus, measured electrical forces, and he published his findings in 1785 to 89. So, yeah, there's like nearly 100 years difference between when they were first found, when they were first presented.
Where did you get that? Where did you get that date?
Britannica.com for both of them.
For Newton.
Britannica.com. I mean, you can just Google when was Newton's law first published, and you can look at the original paper, and it tells you the dates.
At one time, I came up with 3 different dates, Craig. That's why I'm asking you.
Right.
So don't mock me and say that, oh, they're making fun, because I've watched things change throughout 20 years. Stories have changed. So
let me see if I can find the actual paper for you to show you the date.
If we want to move on to some questions so we can kill some dead space.
Yeah.
Otherwise, this is
go ahead.
Right. Anyway, yeah.
Who's better at Google?
From all the information that I was, I'm looking on Britannica.com. It all says that Newton's law was way before whenever Coulomb's law was, and anyway, it goes back to my point that Coulomb's law simply isn't fit for the purpose of these things.
I'll concede it for now. We'll
Okay.
concede it for now. It's not.
Right.
Okay,
So
I've got a
go on.
question here from Extreme Coxver. For the experiment that changed weights, why is it necessary to be on a plane in motion? Wouldn't it be sufficient just to measure the weights at different places? Craig.
The reason that he's doing it whilst moving is because it's to do with, say you're moving with the rotation of the Earth, you're going to be adding to your centrifugal acceleration, which would mean that there was less of a perceived gravitational force on you. That only happens when you are moving with or against the rotation of the Earth, which is why you can measure a difference in weight when you are moving eastwards to westward. Like I said, in the 1900s, a bunch of German physicists did experiments on boats in the Pacific and the Indian Ocean and the Atlantic Ocean, and they all showed a lower reading when the ships were traveling eastward, as the maths shows.
Craig,
Sorry, carry on. Yeah. What were
I
you
just,
saying,
have,
Jim?
I just have a question. Sorry, I just have a question.
Yeah.
So centrifugal force is a force on Earth that we have to calculate for. Then, here's what you're saying.
Yeah, it's an apparent force.
Okay.
And that was another one of my questions. Can you both explain to me your perception of what is a force and what is an apparent force?
Well, an
JM.
apparent force. Oh, sorry. James, go first.
Force is something we can calculate that we can scientifically prove. I'm not a proponent of apparent forces.
What is a force?
You either can or can't. You either can or can't test for it.
Oh,
But I mean,
okay.
what does it do? I mean, like, if you were to describe it to someone, what is
A
a force?
force, it pulls, it pushes or pulls. That's what it does. That's what a force
Okay.
is.
Well, an apparent force is just a force that exists in a reference frame. That's all it is. The gravity exists in the reference frame of space-time bending. The Coriolis force exists in the reference frame of the Earth rotating. Centrifugal force exists in the reference frame that it needs for it to exist. It's an apparent force that you can calculate the same way that you can calculate gravity or the gravitational attraction. So it is, an apparent force is simply something that exists within a reference frame.
Okay.
Can I add to that just a little bit? I've been quiet.
Wait, I wanted to talk a bit more about JM's understanding of fiber optic gyros and what Bob said. Well, what Bob said and what Bob didn't say isn't really important. What's important is the data that was gathered from that gyroscope, and that gyroscope showed.
Actually, it's very important because you can't. If
Well,
you don't even know.
JM, let him finish.
I mean, we all heard
Let him finish, JM.
Bob's words, but
Oh,
like
you
I said,
heard Bob's words, shut up.
that it's not important. What's important is the results that came from that gyroscope, and that gyroscope registered a 15-degree drift. Now, JM, could you please tell me how a fiber optic gyroscope works?
I don't have enough experience in that field. I've never touched one. I've only got theoretical knowledge on this. So
Okay, give me your theoretical knowledge.
It basically takes into account the environment around it based on the lasers and again, like I said, I've got only a theoretical knowledge on it, and it's.
Right. So
I'm not big on talking about shit I don't know about. So
it relies on something called the Sagnac effect. Like I showed in my graphic. I'll get it back up. You've got the two beams of light as they come in. They're split, so you get one going clockwise, one going anti-clockwise. Right. If the gyroscope's not moving, then when the light comes back round and recombines, you're not going to see an interference. But if the gyroscope itself is moving,
Craig, I gotta stop you. Do you have something more?
well, okay, I could go to this one, which looks a bit better. That's just a good visual representation for how a gyroscope, the fiber optic gyroscope, works. Okay, so this shows you it in this way. This is with the gyroscope not rotating. The light based on we know that C is a constant.
I understand the theory.
So based on that, the way that it works is it can't detect anything outside of it. It doesn't know what's outside. It simply can detect what it's on and if that thing is moving. And the only thing that it's on is the Earth, and it still picks up a 15 per hour drift. And as Bob clearly said, it doesn't just pick up the drift in that one axis. It picks up drift in all three axes, which absolutely matches what you would expect to have on a globe. Turn off the audio. As Wolfie he took one of the gyros off of one of his drones, which obviously aren't as sensitive, and that's why he has to move it more. And you can see here when he's moving the drone, the gyro, it represents those three axes of rotation perfectly, and that's what the gyro that Bob had on his desk was picking up, those three axes of rotation, exactly as you would expect, evidenced by this video. So
actually, Craig, that's actually not. I interviewed Bob. He actually picked up movement on one axis, not three.
Okay.
According to, hold on. Let me finish. I'll let you talk.
Yeah.
Quite a bit. Let me finish. Okay. I have an interview with Bob that I did for 3 days. One axis is what I understand it picked up. Now, if I'm wrong, again, I'll have to, I guess, come out and say, hey, look, I was wrong about this. But I'm reasonably confident. I have it on. It's going in my documentary. I'm pretty familiar with what Bob said. Okay.
Okay.
But what it picked up was a drift, but it wasn't the Earth's drift that it picked up. Bob explains in the interview what exactly happened. I'm not going to go into it here because actually that information is proprietary to the documentary, unfortunately. But what I will tell you is that you are misquoting Bob all over the place. And it does matter what he said in context. Because if you're quoting him and then quote him out of context, you're quoting him wrong.
Okay.
That's my main issue.
All right, here, I'm not quoting Bob out of context. So bear with me.
These are the values.
Just, again, listen to what he says, because
picking
this
up.
is the
So
gyro on his
it's not that
desk.
It's picking up motion, because I can set up my mechanical gyro, and it doesn't drift at all.
Nothing. Yeah.
But there is this...
And it is out of context.
Wait,
We don't have
listen,
the whole
listen.
That is in the form of a toroid.
Oh, wait, I'll go back a bit.
Banks to the left, bank to the right, and there's roll.
Okay.
There's the 3 axes. And like I said, it's just sitting there right now doing nothing. And if I zero it out, you can see it start. And these are the values that it's picking up. So it's not that it's picking up motion, because I can set up my mechanical.
No, he did saying about it picking up, right? Yeah, he's saying it's not picking up motion because that's what he believes. But as he was demonstrating there, his gyro is picking up 3 axes of rotation when
Greg,
it's just sitting there.
you just quoted him, misquoted him.
JM, you're interrupting me. Look, we're listening to his words. He has got this gyro on his desk, and he says, when I zero it out... Wait, stop interrupting me, please. He says...
No, you've been interrupting me,
no,
Craig.
I have... Please, JM, let me finish my point here, right? He says...
Let him finish his point.
When I zero this out, it starts to pick up those 3 axes of rotation. Those were his words that we literally just listened to.
No.
I mean...
Go play it again.
So
Play it again. Play it
You
again.
can see it's dropping below the horizon.
Yep.
And if I pull back...
I think that's just like... It was a very quiet video. Let me make sure it's up all the way.
Boom.
It banks to the left, bank to the right. And then this white dot is the yaw.
Yeah, I got you the angle that you're trying.
So there's yaw, there's pitch, and there's roll.
Okay.
There's the 3 axes. And like I said, it's just sitting there right now doing nothing. And if I zero it out, you can see it start. And these are the values that it's picking up. So it's not that it's picking up motion, because I can set up my mechanical gyro and it doesn't drift at all.
Nothing. Yeah.
But there is this ether, this luminiferous ether, that is in the form of a toroid that is rotating down constantly, and this is registering it.
Yeah.
It's that sensitive.
And we know...
Wait.
Just look at a feral cell.
I wanted to say, where's the bit he said about the...
Is picking up the roll, but the interesting thing about what's
right.
going on here is you have movement on all the roll, pitch, and yaw axes, and it's essentially doing this.
See, so, I'll play that bit again.
Of the aircraft.
No, I heard what you're saying, but he's talking hypothetically. He's not talking about
wait. No, it's not. Listen again. Listen again.
All right, and you can see this thing right here, what it is an attitude or an artificial horizon, is what it's called. Okay, and down here you have the very, very fine roll, pitch, and yaw. And you can see they're all moving, right? It's just sitting here, but they're all moving. Now, what everybody is most interested in is they're saying, well,
There you go. It's just sitting there, and they're almost not theoretical.
Wait, you just caught up.
Oh, sorry, I'll carry on.
That 15-degree per hour rotation is picking up the roll, but the interesting thing about what's going on here is you have movement on all the roll, pitch, and yaw axes, and it's essentially doing this. So, and what is picking?
See, so he said that it's sitting there, it's not doing anything, but it's picking up those 3 movements. And I've been over this video many times, and that's why Wolfie actually did that video with him showing that.
Greg, I will concede in this video that he did just say that. However, in context, from my understanding, he's not talking about rotation of Earth. He's trying to explain why it's picking up minute movement.
Oh, of course
That's
he is,
not
because he
15
doesn't
degrees.
believe in the rotation of the Earth. But then,
No.
what his
Craig,
explanation for
you're
it?
making
Sorry,
Let me
finish,
my
please.
bad.
You're
Sorry, carry on,
making
Jim.
leaps here. You search for. He has not ever said that these movements are at 15 degrees. That's not what he said. He said it's making minute adjustments or movements. That I will concede. That's what he said. But that is not. You can't take that to 15 degrees of movement of the Earth and the Earth rotating. I don't get that from this. And
Okay,
I've
so if I
actually-
can respond to that,
JM?
wait, please let me
JM,
respond.
I've got a question. Quick. Go.
Okay, I just want to say that it's nothing to do with minute details. He's literally got the thing there, and he's saying what it's doing. When you listen to that whole video, he even explains how it is picking up 15 degrees per hour. But yes, you're right. He isn't saying it's the rotation of the Earth, Jen, because he doesn't think that it is. He
No,
thinks
Craig,
that
you're
wait.
you're
He
taking
thinks.
two things out of context.
Right, let me finish. He thinks it's the aether coming down in a toroidal form on 3 axes that is causing the interference in the gyroscope, which is why just 20 seconds later in that video, Nathan Thompson pipes up and says, yeah, because it's like a ferrule cell, because he doesn't understand what a ferrule cell is. But so, yeah, Bob is saying that, and you're right, because he doesn't think the Earth is moving. But based on how a gyroscope functions and the Sagnac effect, it can only show the rotation of what it's on, nothing else. That's literally how it works.
So I have 2 questions. First is for JM, and we'll try and keep it short and concise because then I've got a follow-up for Craig. During the debate, JM, you said that gravity is an assumption. The question is, isn't
Correct.
ether also an assumption? And if it
No.
is not an assumption, why not?
I guess it depends on what you define as the ether.
What do you
My
define as
understanding of the ether is my understanding of the ether is the atmosphere around us.
Right, that's really not what the aether is supposed to be. So this goes back to the Mux and Morley experiment, JM. What do you think the Mux and Morley experiment was?
Okay.
Wait.
Well, the Michelson and Morley experiment, the ether they were calling, they were trying to prove the dome or the movement of the stars and not the Earth.
Okay, but I showed you the paper where it's talking about the movement of the Earth. That's from the original paper.
Well, what you showed me was a paper of someone explaining the Michelson and Morley experiment. That doesn't necessarily prove that a paper is actually ethical or correct.
No, that was from the Mux and Morley paper, and the Mux and Morley paper was actually titled "The Luminiferous Aether and the Relative Motion of the Earth." That was the literal title of the paper. Both Mux and Morley knew that the Earth was in space rotating around the sun. The Mux and Morley experiment was designed to detect an aether wind. Like I said, the idea was, like, if you're in a car and you're going fast and you open the window, you stick your hand out, you're going to feel, even if there's no wind outside, you're going to feel wind because you're moving through the air. And because there was an assumption that light needed a medium to travel through, they called it the aether. They said that as Earth orbits the sun, then it would create an aether wind going through the aether. And that's what the Mux and Morley experiment was set up to detect. And that's why they had it on a rotating concrete slab, which they could rotate into, against, and perpendicular to the aether wind based on the movement of the Earth. What they found was that it made no difference. They had 2% kind of interference, but that was within acceptable levels of making mistakes in an experiment.
I've got this right here. The Michelson Morley and Sagnac experiments attempted to measure the change in speed of light due to Earth's assumed motion through space. After measuring in every possible direction in various locations, failed to detect any significant change whatsoever. Mm-hmm. Again, proving the stationary geocentric model.
Right. 2 things. First off, geocentric doesn't mean flat Earth, but apart from that, that's wrong. That's literally not what it did.
I understand it doesn't mean flat Earth. It just means geocentric. I get it.
It disproved the aether. It wasn't trying to disprove the motion of the Earth. It disproved because it was looking for an aether wind. They all knew there was no. They weren't trying to test for a dome or anything because they knew that the Earth was a sphere orbiting the sun in space, and what they were testing for was the aether. No, they were measuring the perceived aether wind that would be there, which is why they got a null result. They didn't detect any aether wind. They had 2%, which again was experimental error. If the aether was a thing, based on what they were doing, they would have detected an interference in the light.
How is it that you can, in ethical honesty, sit there and explain away what Michelson Morley already explained in completely different terms to support your model? That to me is intellectual dishonesty, Craig. I'm sorry.
No, I'm explaining what the Mux and Morley experiment was. It was nothing. They didn't know. They didn't think the Earth was flat. Neither of them did.
You what Michelson Morley himself said it was.
No, Michelson Morley didn't say that. Michelson Morley, but both knew. Like, I'll put it back up again. Relative motion of the Earth. If the apparatus now rotated in the direction of the orbital motion of the Earth, the difference will be in the opposite direction. This is what the entire experiment was set up to detect. It was to detect the aether wind, not the motion of the Earth.
It doesn't say aether wind. It says the motion of the Earth.
No.
What about motion of the Earth? Do you not understand?
Yeah. Listen, if the apparatus now be rotated so that it's in the direction of the orbital motion of the Earth, the difference will be in the opposite direction, and the displacement of the observed will be 2d over. There's the calculation of what they should expect. I should have actually got the page before where it talks about what the aether wind is. But the main thing about the Mux and Morley experiment is that both Mux and Morley knew that the Earth was round and going around the sun, and it was set up to detect the aether wind. That was the purpose of the Mux and Morley experiment. You can try and change what it was set up for as much as you like, but that was the literal point of the Mux and Morley experiment. It was to detect this aether wind.
Jam, are you questioning the validity of this document?
No, I'm questioning his understanding of the document.
And also, can I interject a little bit? Fight the Flat Earth, you keep using it as ether wind, and that is very common to use it as, but it's also referred more to as ether drag.
Yeah.
So that you can think of it more of like an aerodynamic thing. Just like he's saying, it's relative. When they were moving one way through an ether, they should experience drag, and when they move the other way, they should not experience drag. And that difference, the drag should slow light down going one way and then speed light up going the other. That's what they were attempting to measure.
Craig, so I've got a question from Gleam, and it is about Sagnac and the ether. He said, why do you disagree with George Sagnac? And then he's got a quote. The observed interference effects turns out to be the optical vortex effect due to the motion of the system with respect to the ether.
Where is that quote from?
Right.
He did not provide the source for the quote, but he's got it in quotes as coming from George Sagnac. The observed interference effect turned out to be the optical vortex.
Yeah, what was that relating to? There's nothing to do with fiber optic gyros and the Sagnac effect in it. I'd honestly like to see where that particular quote is from so I can explain to Gleam why he's so wrong. Too. But, he's just doing the typical flat earther thing of cherry picking a quote without the rest of it. I would love to see where the rest of that is from, honestly.
Okay. If all of our listeners are listening, guys, this has been my bunch. I think everyone here probably will agree with that, is cite your sources. Do not come in here and make a comment without citing a source. That goes for both of us. That's not even a flat earth or rounder thing. But if you're going to make a comment, Craig knows I won't even answer most people unless you cite your source and I've got a reference point. So I think we agree on that.
He just posted the source in the side chat, but it's in French.
Let me have a look.
Thank you.
Yeah.
I can run it through Google Translate.
I'll look at it.
Well, then he's got a follow-up.
So it's probably just a paper.
Yeah. He's got a follow-up quote from Nature in 1951 by Paul Dirac. Thus, with the new theory of electrodynamics, we are rather forced to have an ether.
again, I'd love to see the context that's in. I mean, the ether has been fundamentally disproven so many times. The Mux and Morley experiment, did it, and then Airy's failure to detect the ether also disproved what the ether was. Gleam, I'm gonna have a look at that. Trust me.
Wait, Craig. Airy's failure, I know a lot about. Airy's failure was to prove the Earth was either spinning or the stars were spinning. One or the other, not the ether. It was to prove the motion of the Earth.
Okay, citation for that.
Huh? Go look up Airy's failure.
Yeah, I mean, I've looked at all the flat Earth that Airy's failure thinks it is, but Airy's failure failed to detect any.
Literally just said.
So in 1871,
literally just said don't provide.
Yeah. In 1871, George Airy's undertook.
Hold on. It's okay. Go ahead.
Sorry.
Right.
Airy's failure attempted to measure drag on light that would change the stellar aberration of light from a suitable star that was almost overhead by using a telescope filled with water rather than air. He had a telescope pointing straight up, and it was to see if there was any drag on the light from the aether.
No, it was not pointed straight up. It was not pointed straight up. It was pointed at an angle.
Didn't he do it over different angles? I mean, I didn't research Airy's failure very much for this debate. I've done a video on it before. But again, it's called Airy's failure because he failed to detect the aether.
No, he failed to detect motion of the Earth.
Okay,
That's
I guess
what he's
you're going to disagree on what the experiments actually were.
So here's a question for you, another question for you, Craig, from Cliff Reynolds. Can you ask Craig how long the ether has been around and whether it is akin to the god of the gaps?
Well, I suppose they first started suggesting.
No, it's
the ether.
actually that. Hey, I know that. Yeah, that's an actual good, legitimate question. When did they introduce the ether into science? And was it a placeholder for something they didn't understand?
So they, like I explained, the aether was kind of introduced when we started being able to measure the speed of light, and we figured out that light behaved as though it was a wave. And knowing that sound needed a medium to travel through, the obvious safe assumption to make is that light needed a medium to travel through as well. So they postulated that space was filled with this matter called the luminiferous aether. But again, that's all been disproven.
I do want to go back and one of the points.
Yeah.
Go ahead.
Craig, is this made up of molecules?
Sorry?
Is the ISS made up of molecules? Yes or no?
Of course it is.
Okay. So when light hits it, it should heat up, correct?
When light hits it, it should heat up.
Yes? You're agreeing to that?
No.
No? So why would molecules that are not attached to the ISS heat up when light hits it? The point is, when light hits it in space, they should heat up. Light is an energy source, right? That's why the solar panels are there.
Radiated.
It radiates heat, correct?
I mean, they use the energy from the light in the solar panels, but like, if you just
so NASA's whole
get to
Craig,
what are you trying to get to with this, so that I can understand where you're going?
You said that there aren't enough molecules in space for the ISS to heat up. Well, that's stupid because
that's not what I said.
The ISS.
I said there, right? Your point was the thermosphere is this massive high temperature. Okay. My rebuttal to that is that
No. NASA said the thermosphere was that temperature. I didn't.
Okay.
I just pulled
right.
out.
Right. Your point anyway is that the thermosphere is this temperature, but and therefore the ISS shouldn't be able to cope in those temperatures. But my rebuttal to that is that the temperature of the thermosphere isn't important because there isn't enough molecules of the thermosphere to transfer that heat energy to the ISS.
No,
if it was in the
misunderstanding energy, because the fact that the ISS is made up of molecules is the same thing as one molecule or multiple molecules that are just at different spaces. But the ISS, by physics, should heat up.
No, dude. Right.
Yeah.
Your point was that the thermosphere is this hot, and therefore
No, my
the
point was
ISS
the
should
thermosphere
melt.
would be this hot.
But the energy coming from the sun,
How did they measure it being that hot?
how do they measure it being
mean,
that hot? I mean, you're
JM,
you're gish galloping it. JM, stop. You're gish galloping and not letting me actually answer any point. Okay?
You walked over me too.
That's because I'm trying to explain, and you keep interrupting me when I'm trying to give you an answer. All right? So, again, the thermosphere being that hot isn't an issue because the molecules of the thermosphere are so spread out that there's not enough of them to transfer that heat energy of the molecule shaken a lot to the ISS because there's not enough of those molecules touching the ISS to transfer that heat there. The radiative heat from wait, I haven't finished. Wait, please let me finish. The radiative heat from the sun is dispersed out a lot, and you're only going to really feel that when you're really close to the sun, planets like Venus and stuff. But you've got all the radiation, all the other fusion byproducts that are coming from the sun, gamma rays, all the visible light and everything, and this causes, say, heat in the atmosphere when it enters the atmosphere and excites the molecules of the atmosphere and causes heat. But the ISS isn't in the atmosphere, and the metals that the ISS are made of, they're not just going to constantly absorb all this energy and store it until it melts, because that's not how it.
So how come the moon then does? Because the moon is a satellite in and of itself, right? So if the moon gets upwards of a couple hundred degrees in the sun, then there's no difference between the moon, the surface of the moon, and the ISS. They're still in the same medium. So explain that, please.
So you said the surface of the moon is a couple hundred degrees.
That's what NASA says. It's upwards of 300, 400, 500 degrees, whatever it is. We can go look it up if you want. But in the sun, it's really super hot.
And the question that I was going to ask is, why doesn't the energy from the sun impart itself onto the skin of the ISS when it's in space?
It should, because they're still molecules.
I mean, you don't think that it's going to be kind of reflecting a lot of that heat the same way? And
what's the temperature of the moon?
Like you said, 200. The moon being the temperature, and it's not the thousands of degrees that would melt these materials. Is the point I'm making here? So even if it's got those couple of hundred degrees temperatures, that's not going to be affecting the ISS. Your whole point was the ISS can't be up there because the thermosphere is that temperature. But the thermosphere being that temperature doesn't matter because there isn't enough of it to transfer that heat energy.
Craig, this is where you don't understand physics. The heat energy would be transferred from the light to the surface of the ISS. Okay? What'd you say?
And you don't think most of that would be reflected into space?
No, why would it reflect it?
Well, JM, how can we see the ISS? It's because light is reflecting off of it.
Well, depending on... Wait. Let's talk about
you're really struggling with the basis of how heat and energy is transferred here.
The mathematics doesn't work out for the size of the ISS for you to even see it. So,
can you show me that? Maths, please. Because
I'm not going to do that right here.
I can show you maths that it does work out.
I'm not going to do that right here.
But how about I show you the maths that it does work out?
Apparently physics is different on the ISS than the surface of the moon. They're in the same medium.
Craig, we're sticking with the heat right now, Craig. We're not going with the distance and visibility.
Okay, but I can do that. It's the heat. So it's not a problem. Like I said, the temperature of the moon, like you said, a couple hundred degrees or whatever, that's not an issue for the ISS.
But the thermosphere is upwards of 4,000 degrees.
And the thermosphere doesn't have the energy.
Great. Let me finish my statement. The ISS, this is non-arguable. This is this is your boys here giving these numbers. They said the thermosphere is 4,000 degrees. Not sure how they measured that, but that's their numbers, not mine. So they've measured it. Okay, we'll go with that because they're the lords of physics, right? Well, physics says when light hits matter, it transfers energy. That energy becomes heat. Heat should heat up the ISS. It doesn't matter about the molecules because the molecules are irrelevant. When the light hits the molecules of the ISS, it should heat up the ISS and cook the astronauts like an oven.
I need to clarify something. Are you talking about the thermosphere or light from the sun? Because you keep bringing up both. Which one is it?
The thermosphere is heated up by light from the sun.
Right. The molecules from the
You realize
thermosphere. Like the thermosphere doesn't have enough of the molecules to transfer the heat energy to the ISS, which is traveling 17,000 kilometers an hour.
The ISS is a big ball of molecules.
And it's made of reflective materials.
Not the whole thing there, genius. No, it's not.
Yes,
the only reflective
it is.
materials on it. No, it is not.
So, all right, then why can we see it? If it's not made of reflective materials, we wouldn't be able to see it.
Because it's made of, well, okay, if you call white a reflective material, it's white. Okay? Fine. But the point is, it's not.
Do you understand how insulation works as well, JM? You don't think that, say, the outside.
You realize that just
theoretically. Listen. Stop talking and listen. Right. Theoretically, say the outside of that was heating up to 4,000 degrees. It's not, because that's not how physics works. And I can take you through the maths another time if you like. But say it is. Do you not think that there would be some kind of insulation? I mean, do you not think NASA would have thought about all these things? Oh, wait. Let me ask a better question. Is the ISS real or not?
No.
Well, then what are you fucking arguing about it for?
Because I'm trying to make you understand.
And also,
how
NASA are so intelligent and amazing that they've perpetrated this hoax on humanity for decades and decades, but they're stupid enough to not think about the fact that the ISS would melt in the thermosphere. JM, think through what you're saying, man.
To put out CGI there, genius.
No, you've never proved that it's CGI because if
I have proven it over and over.
You've proven that there's JPEG compressions. Let's stay on topic anyway.
No, not JPEG compressions. Go read the pictures. It says CGI, genius.
Yeah, so you didn't prove
Hey guys, before this devolves into too much more, clearly we're not going to agree on this topic. Let's move on to gas pressure.
Can I give an example of what they're trying to say? Maybe this will help JM understand what Craig's trying to say. Because JM, inside of a sauna, it is 212 degrees Fahrenheit. Boiling water is 212 degrees Fahrenheit. Which one is hotter? Which one would burn your hand if you put it into? Would it really burn your hand if you put it in the sauna, or would it burn your hand if you put it in a boiling water? They're the same temperature. Keep in mind, they're both 212 degrees Fahrenheit. Which one's going to do more damage?
The difference is the molecules in gas versus water. So, wait, it's still 200 and whatever degrees you said.
How is that different?
Anyway,
we're talking about is heat transfer.
Right, can I get back in? I want to go on to gas pressure. There's going to be an after show, so everyone is invited to the after show. And JM, obviously, I would very much like you to come to the after show as well. There's many people that have some questions for you, but I would very much like to talk about the gas pressure thing, because my question to you is, if you're saying that we can't have this gas pressure without a container, and the container has to have a top and everything, then why does the ocean increase with pressure with depth? Because there's no container on top of the ocean. That's a pressure gradient.
Okay, are you asking, can I answer?
Yeah, that's my question to you.
I didn't say pressure gradient. I'm baffled at the fact that you have a physics degree and you don't know the difference between liquid and gas. Okay? Gas must be sealed in a container.
JM.
I said I'm surprised. That's a true statement. I'm not trying to insult him. But you're asking about liquid. Liquid can be contained in a bowl. Okay? Gas is a very, very specific. It has to be contained in a sealed container. It conforms to the shape of the container, but it must be in a sealed container. You cannot have a gas pressure without a sealed container. You can have water pressure. You can have solid pressure, but you cannot have a gas pressure without a sealed container. This is the issue you keep missing.
Right, I can debunk that easily by saying,
Really? Because that's a natural law, bro.
Well, listen then. Okay, just get a bowl.
Let him respond, JM.
Yeah, get a bowl and fill it with sulfur hexafluoride. You've then got gas that is pressure and it's not contained, and it will just sit there.
That's because, one, it's not a gas pressure. It's a gas sitting in a bowl. However, as all gases that are not in a sealed container, they all eventually leak out. It just happens that hexavalent sodium is also, it leaks out much, whatever it is. It leaks out much slower. But it still does dissipate, my friend. It will dissipate.
So
it just dissipates at a much lower rate.
You're telling me
there's still no gas pressure in the container without a lid on it.
I just told you.
Measure the pressure.
There will be a pressure that gas has.
No, you can measure weight.
PSI.
No, you can measure weight, but you cannot measure pressure.
Well, you can measure atmospheric pressure.
That's because you're already in a container. The 14 psi, you're already in a container.
Okay, well then we have to talk about the pressure gradient that we have, and why is that a thing?
Because you have things heating up and cooling down. On YouTube, there's a video of a guy who created in a propane tank, cooled one end, heated up the other end, and it clearly shows two different pressures on either side of that container.
Okay, so why is there a constant pressure gradient, right? And here's the thing. The pressure gradient is the same from the floor of the Sahara to space, from the floor of the Arctic to space. There's still...
No, it is not.
It's still 14.7 psi up to
it is not
0 psi. So you're telling me I'm going to get you're telling me I'm going to get a wildly different barometric pressure at one of the poles to the Sahara Desert? Are you telling me that it's not a 14.7 psi?
What I would tell you is it probably would be slightly different the higher you go.
No, that's not what I asked. I'll state the question again. Okay, you've got this, wait. Let me explain the question again, because I'd like a very specific answer. Okay, so you're saying that it's to do with temperature. Okay, except the atmospheric pressure gradient from 14.7 psi to 0 exists both in the Sahara Desert and the North Pole. Why is that?
Well, it varies by points, but because it's both are we at sea level, or what elevation are you at?
Yeah, but you just asserted it was to do with temperature. So
pressure, well, temperature's part of it, yeah, but pressure also changes. Pressure also changes based on elevation.
Yes, because of the pressure gradient.
No, well, and the amount of pressure you have on top of you.
Yeah, that's called a pressure gradient, JM.
Right, exactly. I get it.
So your argument of it's caused by temperature is nonsense, because the pressure gradient, the pressure gradient exists whether you are in the Sahara Desert or in the North Pole. So why is that pressure gradient there?
Actually, you're wrong. The pressure gradient does change based on temperature too. It just changes at a very different rate depending on the height at which you're at. If you're both at sea level and you're in the Arctic versus the Sahara Desert, your decimal point numbers will probably be different.
Yeah, very slightly. But what you will find is that the gradient, the reduction in pressure, is the same as you would if you took a point in the North Pole up to space and then a point from the Sahara Desert up to space. Then that gradient is the same. It's the same all over Earth. There is, and you're missing the main point of the fact that we have a gradient, and that gradient we know goes to 0.
No, we don't know it goes to 0.
We absolutely do. And the ISS is evidence of that, because we know the ISS is traveling 17,000 kilometers an hour.
But
that's been proven by. We know the ISS is traveling 17,000 kilometers an hour because it was measured by Red's Rhetoric and Astronomy Live. I can link the video to showing you exactly how they did it. But they managed to not only calculate the correct height of the ISS, but the speed of the ISS. And they got the numbers that were the same as what NASA tell us they are. So we know the ISS is going that speed. And if it's going that speed, it cannot be in our atmosphere because it would be on fire.
What's your point?
We know the ISS is in space. It
No,
can't be
the
in the
ISS isn't
atmosphere.
even there.
Oh,
It isn't even there.
Well, it is, and it's been proven that it's there.
It's been proven it isn't there.
No, it hasn't.
Sure, it has.
How?
Just because you don't accept the proof.
Tell me
doesn't
when it
mean
was
hasn't
proven that
been
it's not there. Because I can
I just gave
literally
you
show.
proof.
I can literally show
I just
you
gave
the
you
evidence
proof
right
that it
now.
could be there based on the temperature rate, the temperatures. Of
No,
the
I
thermosphere.
can give you empirical evidence, JM, that the ISS is there.
Empirical evidence.
Yes.
Really?
Yes.
What empirical evidence are you going to give me that's going to have any validity to it?
Literal people
JM,
using their
if
eyes.
I may butt in here for a second,
Yeah.
I've photographed the ISS twice going in front of the sun. Personally.
You have photographed an image going in front of the sun.
Something moving in front of the sun that if you do the calculations, it was moving at 25,000 kilometers an hour.
Well, okay, I'm not quite sure how you calculated that, but
Anyway,
Well, the way
we've moved a bit off the topic,
I
and
have no doubt
I really want to nail this point before it gets taken away. JM, there's a pressure gradient. Tell me why.
because all gases are different, have different weights.
Please.
Everything. There's a pressure gradient from what you would call space or the dome, all the way to the depths of the ocean, based on.
This leads to another question, JM. Drew G asked JM if he has evidence of the container.
The gas pressure is the evidence of the container.
But gravity is the container.
Of the container itself. The container itself.
There
Is
is
there
no
anybody that has
difference
evidence
in
of the container?
Yeah, gas pressure is the evidence of the container.
What you're doing there is you're
That's
saying
not what
A,
I'm
therefore B.
No, I'm not.
You
Because
are.
the definition of
We would
gas
like some
pressure-
actual evidence of the dome, but it's still moving away from my point.
Oh,
right? And
okay, that's a different question.
I
Wait.
know. No, I'm not moving on to a different question. I haven't finished with this point
okay.
because this is very fucking
We'll come
important.
back to the dome then.
Right. There is a pressure gradient. We know there's a pressure gradient. Please explain to me with accurate maths so that I can calculate what pressure I should have based on my altitude according to what you are doing. According to your understanding of gas pressure and whatever you're saying is causing this gradient, can I please see the maths that will allow me to calculate my pressure based on my altitude?
What you're doing actually is not a fair question. You're asking me to provide you
then. Because
I can't right now. No, I'd have to go down.
I can give you the maths to show it how it works on my side. 100%, absolutely. I can based on the calculations I can give you.
Whole life, Craig,
wait,
on
let me
math.
finish.
Not
on math, on observations as well.
Then it's your floor.
JM, right? Not only maths, but direct observations that I've had in my own life during my training in the Navy, climbing up fucking Brecon Beacons in Wales.
I'm about done
right,
with this, guys.
So at the bottom of the mountain, my packet of crisps, salt and vinegar in my bag. It was nice and crumpy. By the time we got to the peak of Brecon Beacons, sitting up there having our lunch,
Blake,
that
did you hear me?
bag was a big fucking massive
I heard you.
thing. So
You got this next. The question, JM, is do you have anything that you can use to predict the pressure gradient? And
To
where does that
predict it?
basis come from?
yeah.
Yes.
No, you'd have to measure it according to the temperature and the height that you're at. I mean, you can make an assumption, but the assumption isn't going to be accurate because the weather's always changing depending on where you're at on the earth.
But what would all the information you would need to make that prediction?
Well, I guess you'd need the temperature of the air at the height or the altitude at which you're at, and you'd need some way of measuring the pressure.
But
I mean, it really isn't.
We're not talking about measuring.
Again,
We're not talking about measuring the pressure yet, though, JM. We're talking about making your prediction for what the pressure is going to be.
This is kind of out of my. Without doing research on this, I'm not ready to answer this question.
Okay.
Okay.
30 seconds, Craig. From your perspective, how would you do it?
How would I calculate the We know what the
Yeah.
we know what the pressure gradient is from 14.7 psi to 0 psi. Based on readings from aircraft that can show us what the pressure is, we could easily, and based on Newton's gravitational law.
But I said the same thing.
Craig.
Y'all blew me off. This is
the
crap.
question, Craig. Yeah.
Sorry,
No,
clarify
Craig,
the question.
I'm asking is, what data would you need
what
to
data
make
would I
the
need?
prediction?
Thank you.
To make the prediction.
Okay, to make the prediction, I would need to know the composition of the air, the temperature, the altitude at different points, and Newton's law of gravitational attraction
Did I
to
not just say
calculate
that?
what's putting stuff down.
Did I not
The
just say
one
that?
thing that was different, JM, the one thing that's different, though, is he added gravity into it as the downward force.
I understand, and
And
I
what
would.
we were trying to get
just,
to is what you... Yeah, what is your downward force causing that? That's kind of the point of this.
Well, what
What is your downward force causing the gradient?
What you guys are calling downward force, I call weight of the atmosphere.
And define weight for me.
Weight is a pressure.
No, weight is mass times acceleration.
I understand that's your definition of it.
No, it's the
Mass is
definition,
just
and it's how you calculate it.
Mass is calculated by weight. Go look up any mass. Any mass will give you the atomic weight of that object.
And
It's not rocket science.
and how do you calculate weight? You have the mass times the acceleration.
What you're calling mass is not mass. It's weight.
No, because weight is mass times acceleration. They're not the same thing, which is why astronauts weighed less on the moon, because the acceleration part of that equation was 1/6 of what it is on Earth, which is why your weight, you don't really have a weight. Your weight is the force of gravity acting on your mass, which is why that's also evidenced by the fact that at different points on the Earth where there is slight differences in the radius of the Earth, you can actually weigh different based on the mass of the Earth underneath you, because the acceleration is different.
Okay, if we could move back to the question that was in general reference to this with a pressure gradient. Is there any evidence of a physical container, JM?
Physical evidence. Sure. The stars themselves are a proof of the dome when you understand what you're looking at.
Basically, I think the question boils down to, has anybody found the dome itself?
Yes. Admiral Byrd found it. Lost 13 planes.
Explain that, please.
Flying into that object. Which is why the Antarctic Treaty exists, because funnily enough, right after that, the Antarctic Treaty was signed, where 70 some odd countries agreed they're not going to go to the Arctic. Why? Because they don't want people knowing you're in a container. Sorry, that's the historical fact. Whether you accept it or not is not my problem.
Greg?
Yeah, that never happened.
I know, Craig. You know,
like
I know.
Yeah.
I mean, there's plenty of military people here, and some of us have actually been to the Arctic. There's
not Arctic. I said Antarctic.
Yeah, sorry, that's what I meant. And
Exactly.
the Antarctic Treaty wasn't put in place to stop people finding a dome. It was put in place to preserve the Antarctica as the last place on Earth. Wait, I haven't finished. All right, carry on. Interrupt me. That's cool.
Well, because you keep the way you word things is very aggressive and talking down to people. So here's my question. I'm a government. I don't want you to know something. Do you think I'm going to put it in a document that I don't want you to know it? Or am I just going to make it hard enough for you not to be able to accomplish your mission? Mr. Military Guy?
Can you say the question again?
Sure. I'm a government. You're a peon. I don't want you to do XYZ. Do you think I'm going to put it in a document? I don't want Craig doing XYZ. Or am I just going to make it hard enough that you can't do XYZ?
I mean, if the government didn't want me to do something, they would probably tell me not to do it. But
Well, they have told you not to do it. You're just apparently not wise
the-
enough to understand that that's what
The,
they
the
told you not to
Antarctic
do.
Treaty doesn't stop you going to Antarctica, though, JM.
Absolutely it does.
No, it doesn't. You can literally book holidays to the South Pole. There is. I mean,
Anyway, you book a holiday. You book a holiday to the South Pole. I'd love to see that, Greg.
dude. At last count, there's
JM,
17.
I'll ask you this.
Wait. At last count, last time I looked, there's 17 different companies offering chartered holidays to the South Pole. Not only that, but recently one more orbit. Most recently, one more orbit did a polar circumnavigation from the North Pole to the South Pole, proving that they're both a thing. I mean, you can deny going to Antarctica all you want, but you don't have to have special permission to go there. You can go there all you want. You're probably going to die because it's really fucking cold. There is areas off limit for research. Yes, no one's denying that.
You want to negate all the people that have gone there and been turned around?
I've not heard ever one person prove that they've been turned around.
Let's go do some research, Craig. Come on.
Do some research.
There's tons
So
of
that,
I'll save that
was
for
going to
another
be my
time.
question, because this is the same question that I asked Mark Sargent. Is if you have the claim that you can't go to the Antarctic, do you know anybody who has honestly tried and couldn't?
I actually know a pilot that flies to the Antarctic on the monthly basis.
And
He's
tell us more about that if you can.
C-130 pilot. Upon being asked about flat Earth, he won't talk about it, but he will not admit the Earth is round either. He will tell you you can't go there without so many special passes. It really is not viable to go there. The only reason the Antarctic Treaty even exists is to give the illusion that people can go there. But the people that say they've gone there, they are scientists, yes, that have gone there. But all of them have been in contained situations, in contained camps, not allowed to go out and venture. You can't just go and trek across Antarctica. That's not even a possibility. So for us to even argue this is really, a moot point at this point.
I would say that you can't argue that side, though, JM, until you can show me someone who went through the hoops to do it and was denied.
Because I can look on the internet and find people saying that all day. You're right, but there isn't one video of someone being turned away by some military pseudo government, protecting the Antarctic. And here's the thing, right? Wait, I'm talking, all right? Here's the big thing about that. If these people are being turned away, that means that Antarctica is being policed. And on the flat Earth, it's going to be fucking massive because it's round the outside. Have you any idea how many ships and personnel it would take to be able to police that? It would be the biggest military force on the planet.
Do you know what electronic net is? Do you know what an electronic net is?
Yes, I know what an electronic... JM, do you know how many... how are you going to stop people getting there? You're going to have boats all over the place. You're going to have people stationed all over the place.
No, you don't need that.
So I'm just going to go. Who's going to stop me then?
All you have to do is put an electronic net around the place where you don't want people to go, and a sensor that tells the government, "Hey, this person has broken the net." Okay, it's that simple. But here's the point. In order to even go to Antarctica, if you read the Antarctic Treaty, which I have, you have to go through like 12 or 13 layers, interesting number, to get those many permits to even go.
No, you don't.
Dude,
you don't
go
need
read
any
the
permits
fucking...
to go.
Let him finish, Craig.
Yeah, you do. Go read the fucking treaty. At this point, I'm done. For you to look at me and tell me no, you don't, is stupid, dude. I've got a copy of it right here.
Dude, they've literally posted the vacation sites in the chat for you.
Right. Fuck. I don't care what they post in vacation sites. Here's a copy of the treaty. I've read it. Have you? No.
Yes,
Why?
I have. And it doesn't say anywhere you're not allowed to go there.
You're right. It doesn't say you're not allowed
There we
to go
go.
there.
Thank you.
But it's some... Okay.
Let him finish, Craig.
The government can put things in places to make it so hard that it's not practical, Craig.
Oh, so
Are you denying that?
I'm allowed to go there, but it's not practical. Is that what you're saying?
Craig, you can't jump on a boat and just go to Antarctica. They will
Yes,
turn
I
you
can.
back.
No, they
No,
won't.
you can't.
Can you show me proof
fucking
of
do
that?
Fucking do it.
Craig,
You
I
show
would
me-
say that to hold the same level of proof for JM to say that you can't go there, before you say that you can go there, you'd have to point to the same thing, that somebody did do it.
Okay, recently they did during the One More orbit. They flew over it. There is
That's not a boat, though.
a boat going there. You mean you want
Someone physically going there. Yeah, you can't orbit it.
again?
It
So
was a plane.
the vacation sites that take you there, they take you there by boat. So I could just show any of those vacation sites that take you there.
Yeah, that's not a
they've got
proof.
But he's
charted
talking about
boats.
you as an individual.
Me as an individual, well, I was there on the submarine, but I don't have videos of that. I didn't take videos when I was on a submarine. But there is, you just saying you can't go there and saying you're going to get turned away isn't evidence of anything, when I can literally show you people going across Antarctica. Like, there was recently the world record women's team that walked across Antarctica.
Walking across ice wall.
No, they walked across Antarctica.
No, you can't walk across Antarctica. All you can show
Apart
me are
from they
videos
did.
of people walking
Let him
on an
finish, Craig.
ice wall. All you can show me.
Okay, so you're just saying it's an ice wall and it's not Antarctica, but you're not providing any evidence. Whereas,
It could be anywhere, Craig. That's
okay.
my point.
so basically, I could show you evidence and it's not going to matter because I can show you evidence. I can show you so many people recording themselves going across Antarctica.
Showing a picture of people walking across ice is not evidence, Craig.
Okay, but when they can show you things like their GPS location, and stuff like that, and all these people had GPS receivers on them in case shit went sideways and they needed to be rescued. So when you can correlate all that data with where they're supposed to be, then there really isn't
correlate
an
all
argument.
that data and come back and talk to me then.
Well, JM, here's the
With some
thing.
proof.
No, you're the one claiming that you can't go there, so you need to provide evidence that you can't
No,
go
no,
there.
no, you're
And,
saying you can.
and when I
But you
asked you
can
the
provide-
question, does the Antarctic Treaty say you cannot go to Antarctica? You admitted that it
This
doesn't
is
say
reverse
that.
logic, Craig. This
Yeah.
is reverse logic. This is what you do. You constantly reverse it back on me and put all of the onus on me. You need
Because
to
it
provide
is.
the proof.
I told you I can give you the proof, but you're not going to accept it because you're just saying that could be ice anywhere.
Well, a GPS location is great, but you can't correlate a GPS location and someone going across the Antarctic by GPS.
JM, if I may,
Yes, you can.
what level of evidence would you need from the globe side to show that someone did actually go across Antarctica? Because it seems like it's a moving goalpost. What
That
evidence
is a
would you
great
need to be convinced somebody did it?
Short of going there myself, I don't even have an answer at this point for that. I don't know because
Then it's a moot point to even
Yeah.
discuss, I
Yeah,
would say.
can we just leave it at
Correct.
there?
I agree.
The Antarctic Treaty does not say that you aren't allowed to go there. Can we all agree that?
But there are restrictions placed on by governments that make it difficult to go
that
there.
I will agree.
I mean, not that difficult because you can book a vacation there.
Well, but the vacations don't take you
allegedly,
across
Craig.
Antarctica. They take you to the shelf.
Yeah.
So you can't. Yeah.
The governments do make it difficult to allow a human being to trek all the way across Antarctica for whatever reasons the governments claim. We can all, I think, agree on that.
Yeah, but it's
Yeah.
not that difficult because people do it all the time. So,
No, they don't, Craig.
So
You can't
okay.
prove it all the time.
I,
When I've got military
Yeah.
personnel, my evidence at this point is weighs far higher than yours. When I have military people telling me that you cannot go without strict restrictions, the Antarctic Treaty says you have to have strict restrictions, and you want to play this off like, see, I told you, he doesn't know what he's talking about. But I just gave you more proof than you gave me.
No.
Hey, JM, we've also got a member of the Veterans Talk community that spent, I think, 2 or 3 years into Antarctica. Geisview.
Okay. On a
So-
pace, on a post there or what? But again,
Yeah, he
just
was,
going to
stationed-
Antarctica, assuming that I'm right and it's a ring, or I don't care what shape it is, just going to Antarctica doesn't prove that it's that it's the continent they say it is. Doesn't prove that.
Okay, let's move on then, because clearly we're not going to agree on this one.
Yeah.
Craig, have a lighthearted, not a lighthearted question, but a lot easier question. What was it? What is the best home test someone could do to prove rotation?
The best home test that someone can do to prove rotation would be something like the experiment I showed, setting up your own kind of Foucault's pendulum, and using that and a bit of vector mathematics based on the sign of the latitude that you're at. You can calculate your distance to the North Pole. Anyone that has access to something that's really tall, like a block of flats, could do this experiment themselves, and wherever they are on the Earth, based on the amount of drift that they get, they could calculate their distance to the North Pole. And I think that alone, the fact that you can calculate that distance based on the drift, is an irrefutable evidence of the fact that the Earth is rotating.
Well, you know what? The other thing that I would say too, as far as Antarctica is concerned, if you look at the treaty, all of the restrictions have nothing to do with vacation. They're only to do with exploration. So for you to say people can go and vacation there, that's not true, Craig. You better go do your research, because the Antarctic Treaty does not allow. It's solely exploration.
Jam, we're moving on from that.
As far as I know about the Antarctic Treaty, the only real restrictions are on like harbor and stuff. But that's for another conversation. Anyway, pendulums and the drift that they show are an excellent, and also a simple gyro compass, which uses a spinning flywheel and can show you true north.
Yeah, at some day I'd like to try the Foucault pendulum. I just don't have the place for it right now, and my spare bedroom is occupied with a Cavendish.
Yeah.
And what does the Foucault pendulum prove?
That there is a rotation, because the Earth is moving underneath it. Because
so I've got a question for JM, unless you want to talk about that more.
No, it's cool. I can take JM through the maths on it in the after show if he likes.
Yeah. JM, can you talk to us about the Southern Pole Star and how that fits into your model?
Southern Pole Star, as far as I understand it, is an optical illusion. That's as much as I'm willing at this point to talk about it.
Okay. So this would be a question for both of you, and this one's from me. This is regarding the Coriolis effect. Why would the Coriolis effect affect a bullet, but not a plane? Craig.
There's a difference between powered and ballistic. So if you're in a plane, you've got engines and stuff that are powering you, and the Coriolis effect isn't like a massive force. But if you are an artillery shell being fired south, that doesn't have power. It's just ballistic. It is, in the air without any other forces acting on it. So it's much more susceptible to the Coriolis force. This was evidenced in World War II when British tanks, they did the calculations that they thought it would work both ways. But when they fired south, they found that their shots were deflecting twice as far from the target as they thought. So when they then redid the calculations and took into account the rotation of the Earth and the Coriolis force, they managed to get it right. So, yeah.
Do you know I don't know if it's a myth or not, the myth behind why that happened?
No, I'm not really sure of the entire story why that happened.
Because the manufacture of their sites didn't account for the ships ever being in the southern hemisphere.
Oh, yes. Now you say it. So yeah, when they started firing based on like what the manufacturers had said, it went twice the distance the other way that it should. So then when they actually took into account and made it right, they could hit it. So that was evidence that the Coriolis. But the answer to your question is that there's a difference between ballistic and powered. If you're powered, you've got other forces acting that are counteracting the Coriolis force.
And Jam, what is your opinion on that?
Again, doing a search on the internet, does this affect planes and helicopters, talking about Coriolis effect? The answer again is yes. If the Coriolis effect were real, Coriolis force do affect airplanes, at least as far as winds are affected by the Coriolis forces. Whether or not Coriolis forces on the planes are important depends on how long the journey is. Planes and bullets are both affected by Coriolis.
But would you say that a powered craft auto-corrects for Coriolis, whereas a bullet or ballistic
Absolutely
object
not.
cannot?
Absolutely not. And I've got tons of pilots that are going to testify to that. And I've got a mechanic
JM,
that works on the.
can you tell me
Can I
why?
finish?
Wait, let him
Yeah,
finish.
sorry.
Let him finish, Craig.
Sorry, yeah, my bad.
I've got high-level airplane mechanics who work on these systems all day long and will tell you there's no mechanism in a plane that calculates for Coriolis. Do you realize that the SR-71 Blackbird, which flew at ungodly speeds, Mach 3 and 4, would literally have 4 to 5 Gs constantly upon the pilot trying to go around the curve of the Earth at that speed? It is so ridiculous. Most pilots will tell you it's completely insane to think that any pilot flying at over Mach speeds would be calculating for the curve. It's not even a reality.
Right. JM, can you tell me why a powered thing like a plane wouldn't correct for the Coriolis force?
Because there is not one.
No, that's not what I asked. Assume there is, and tell me why a plane wouldn't compensate for it.
It would. It couldn't. If the Earth were moving below the plane at an opposite angle at which the plane is flying at, the plane therefore would have to compensate at landing, especially if it's flying in an opposite direction. So the fact that no plane does that is proof that there is no such thing as Coriolis.
Right. That didn't answer my question. So
Absolutely, I did. It wasn't the answer you're looking for. Doesn't mean I didn't answer your question.
Let me rephrase the question. So why would a powered plane act the same way in the Coriolis force as an unpowered bullet?
They don't. I'm not sure what you're trying to get me to.
Yeah, I
what
think
road
the
you're trying
question's
to
a
get
little
me
unclear,
down.
Craig.
All right, I'm trying to
Very
ask JM why he thinks.
You're trying to ask me a question to an answer you already perceive exists, so that I give you an answer that you accept.
I'm trying to ask him why he thinks a plane would be affected in the same way as something that isn't powered when there is other forces acting on the plane that are much greater than the Coriolis.
The motorized, the mechanized propulsion unit, let's call it that, of any aircraft is irrelevant to the motion of the Earth below it. I'll make it really simple for you, Craig.
Well, I don't think you know what the Coriolis force is. That's the problem.
No, I don't think you understand what the Coriolis force is.
No, I explained it earlier pretty well. I don't think you listened.
I read it to you. I just read it to you.
So, as I explained earlier, the Coriolis force is to do with conservation of momentum.
Let Jan finish.
Sorry. Okay.
Let me finish. You want to play both sides. We've had this discussion before. One side, you want to say the Coriolis force exists, but it can only exist if the atmosphere of the Earth is not tethered to it because of the reference frame issue. Then you want to say that it's tethered to the Earth. You cannot have it both ways, Craig. You need to pick one side, preferably the definition of Coriolis force.
Okay, the Coriolis force is not the difference in the atmosphere moving and the Earth moving. That's not what the Coriolis force is. The Coriolis force is to do with the conservation of momentum of your angular velocity whilst you are moving out of that reference frame. Imagine bands around the globe, right? One around the middle, and then one underneath it, and it gets littler and littler.
Okay.
All right.
Let me read the definition.
JM,
let him finish,
stop
JM.
talking and let me educate
Right.
you, okay? So, if you are on the equator,
Don't talk
as
now,
you flat
Craig.
earthers keep saying, it's 1,000 miles an hour, okay? You have that angular velocity of 1,000 miles an hour. And
Before you keep going, are we going to start insulting?
Stop interrupting me.
Are we
Jan,
gonna
That's
continue
why
on
I
that-
insulted you, because you keep interrupting me. All right? So
Yeah, because
you
I
have that
know-
angular, you have that
No
angular
talking down.
velocity of 1,000 miles an hour.
Hey, gavel. Stop. We're going to try and continue a polite conversation. Craig, no more talking down.
Sorry.
Finish your thoughts.
Okay, so
Nothing else like that.
the Coriolis force is to do with your conservation of momentum. All right, it is if you're at the equator and you're traveling 1,000 miles an hour, as you flat earthers keep saying, that's your angular velocity. As you move into a reference frame of a lower angular velocity, you maintain that momentum of being in the 1,000 miles an hour, and that causes a drift ahead of the rotation of the Earth. That is what the Coriolis force is.
Can I speak now?
Yeah, I've finished. That's how a conversation works.
Excellent. The definition of
Craig.
the Coriolis effect: an effect whereby a mass moving in a rotating system experiences a force, in quotes, the Coriolis force, end quote, acting perpendicular to the direction of motion and to the axis of rotation. Did you get that?
Yeah, that's what I just
On
said.
the Earth.
That is literally what I just said.
The Earth, the effect tends to deflect objects to the right or left, blah, blah, blah. Now, that definition says that the atmosphere is moving in a separate reference frame to the Earth.
Please tell me where it says that, because it didn't. Read it again, JM. Go on.
No, I've read it already.
You
You
did
need to
well.
read it
You read it and then said something completely
I know
different.
you're talking about Coriolis effect. So,
Well, yeah, but you read a definition and then said something completely different. That confuses
no,
me.
I didn't. Just
You
because
did.
you misunderstood what it said.
It
You
didn't say
read
anything
the
about the atmosphere. All right, I've explained to you what the Coriolis force is.
Craig,
and
I don't
it's
give
the
a shit what you explained. I just gave you the fucking definition, dude.
Yeah, and your definition
Damn,
that
calm
you just
down.
read backed up what I said.
To the direction of motion and to the axis of rotation. What do you not understand about that?
I understand everything because that's what I've been saying.
What is the difference between your position and his position, JM? Where are your positions different?
Because the atmosphere is moving in completely opposite reference frame to the Earth below it. That's what the Coriolis effect is.
The atmosphere isn't moving in a different reference frame. The atmosphere is moving with the Earth. That's what I don't understand.
Because the last time we were on here, you said it was. So
No, I didn't.
ask Nathan Thompson. We've had a discussion about this.
Nathan Thompson
Again,
is impossible to talk to. No, the atmosphere is rotating with the Earth. Okay, the atmosphere is in the same reference frame as the Earth.
There is no Coriolis.
Hey, let him
effect.
finish, JM.
No. Wow. So, yeah, I
Okay.
think we need to move on because
Let's-
he's
we're gonna move on.
literally backed up what I've said and then got confused.
Okay. Question from Sean Hufford, and this is regarding the SR-71 comment that it would be doing 4 Gs to continue with the curvature of the Earth.
I said
Have you done the math? Okay. Have you done the math to do that? Because
I have not. I did have a pilot do the math with me. I don't have it in front of me, but I have the math somewhere because we're going to actually talk about it in the documentary. So.
Okay, because Sean says that his calculations show that the speed for 4 Gs would be 35,000. He just doesn't say kilometers or miles.
I think that's kilometers an hour.
So so it'd be 35,000 kilometers an hour, the shift in vector to get 4 or 5 Gs. So I don't know. That's Sean's question.
Yeah, if you're constantly having to calculate for the curve of the Earth, that's that shift in momentum. It's just going down.
Okay.
So the force is pushing up against it.
Okay. Hopefully an easy question for you, JM. And Craig, whenever you want to call it, we're over 2 hours. I'm good.
Yeah.
I'm the boss, so I get to stay out as late as I need to.
I think a couple more questions, and then I'll read super chats,
Okay.
and then we'll get the after show arranged.
So JM, if weight, and this is from Darth Weezus, if weight is a pressure, what is the downward force that creates that pressure?
I would say be electrostatic for the Coulomb's law.
Okay.
Is what creates
Do you, and then, okay, this is another question kind of regarding that, and this is from Negative Exponents. Do you know what apparatus Combs used for his law, how he measured it?
No, I'd have to go back and no, I don't.
The second part of that, apparently it's very similar to Cavendish's torsion bar.
Yeah.
Okay, but they're not. I mean, they're still
Not the same experiment, probably the same general thought process for the experiment.
Okay, well, I can do a thought. I can do a thought
Another
experiment.
question. Yeah. So another question for JM, and I'm not trying to, again, like I said in the beginning, everything's going to be focused on you, JM.
You're fine.
So why is it acceptable for flat earthers to use lasers and high-powered cameras for their experiments? If those devices are man-made, doesn't that make it an unnatural experiment? And that is from Sandy Smith.
No, well, okay. I understand the argument that's being brought up. I don't have a problem with using technology in experiments when we can do the experiment based on a natural phenomenon in nature, okay? But the experiment needs to match what the observation is, or needs to be able to capture that phenomenon. That's the difference. For example, if we're talking about curvature of the Earth, a laser is just a higher grade of technology than they would have used a couple hundred years ago, because we actually have a straight beam that can go for miles and miles, and actually now test, for example, 8 inches times mile squared. We can shoot a laser beam 10 miles and be able to measure that distance. It's the same as running, whatever measuring device you wanted to that long to calculate for curve. Or a camera is another set of eyeballs, for example. To me, the Cavendish experiment is different in that it's not measuring. It's not something we perceive in nature. So it's a completely man-made, self-contained experiment. Has nothing to do with what we perceive in nature. Therefore, from my perspective, it's not a viable experiment. Does that make sense?
And I think we'd all have our disagreements on that. So. So Mandelbrot just asked this question for JM about electrostatic force. If you think that's what gravity is, wouldn't putting an object in a Faraday cage then negate the electrostatic force causing gravity?
That's a good comment. We've actually briefly talked about it. Not necessarily, because I don't know how I'd explain this, but the Faraday cage eliminates the electrostatic charge within the Faraday cage. It doesn't necessarily eliminate the electrostatic charge of the object being measured.
But isn't the force that you would talk about the interaction between the electrostatics of the two things?
Well,
why would one act differently?
Because what charge does the Earth have?
Not very much.
It's negative. What charge is the ether that they say doesn't exist, or what we call the dome, is a positive charge. The whole system is electrostatically charged. So just because you can eliminate the electrostatic charge within a small area does not remove the electrostatic charge of the entire atmosphere.
Okay, but when you are removing one of those charges, surely then the interaction of the object and its surroundings would be different to outside of the Faraday cage. You're changing some of the parameters, right?
I'm sure it is, but without doing that experiment, you're asking me to comment on an experiment that I've never done, nor.
Well, the fact is that people don't float in a Faraday cage, right?
Well, no, of course not.
I have a Faraday cage at my office if we want to experiment with it.
Yeah, and I think my point is that if the Faraday cage is able to eliminate even part of the electrostatic charge, then how the object acts should be different in the Faraday cage as to out of the Faraday cage, right?
Well, and it might, but you're assuming that it would float, and that may not be the
that was
case.
just a flippant comment, but there should be some difference, and
There should be, no, I'll concede that, Craig. Sure, there
Okay.
should be a difference. Yeah.
So, and this is something that I can actually experiment with. I have a Faraday cage at my office. It's for processing cell phones and blocking them out, and it's even got gloves so you can reach inside. So I can test it to make sure that it is a legitimate Faraday cage, and I also have scales that we use to weigh drugs down to the minute level. I will weigh something outside the Faraday cage and weigh something inside the Faraday cage to see if there's a difference.
So,
Viable
so
experiment?
here's a fun, yeah, sure, yeah. Here's a fun thought experiment. Let's assume we're in a vacuum, no gravity. And it doesn't even have to be a vacuum. Let's just assume we're in a place with no gravity. Okay. For this thought experiment, I put people in space because it's what we all can visualize because that's what we've been programmed to see. But let's take matter, forget the physics of a vacuum for a minute, and let's take liquid, solid, and gas. So we have a gas of water, we have a liquid water, and we have ice. And they're just in sheets, okay? And they're just floating there. They're going to continue to float there for how long?
With no outside influence.
I'm not trying to trick you. This is really simple. I'm not trying to trick you. Just
So
okay.
they're
gonna
floating there
float
with no outside influence at all.
Correct. Nothing. Yep.
Well, then wouldn't Newton's laws
Infinitely,
say
right?
that it's not going to move without an outside force acting on it?
Right. Of course. So then I take a steel ball and I place it on top of this level of water. Now what happens?
Well, if there's no directional influence, nothing. The ball would just sit there in the water.
Right. Now I take a very powerful magnet. I put it underneath the ice block. Now what happens?
The ball, assuming it's of a magnetic material, would be pulled
I said
towards
steel.
that. Yeah. Okay. So
Right.
it's still, well, yeah. The ball in that case would be pulled towards the magnetic source. Nothing else would, especially not the water, as water's diamagnetic.
It would go through the gas, through the water, hit the ice, and then, as far as it can go to the magnet.
Yeah.
So there's your thought experiment for what you guys call gravity, which I call Coulomb's law.
Okay, but my problem with that is that gravity affects everything, and they're the same. The gas, the water, the ball, everything. In your thought experiment, the only thing being affected is the steel ball. And nobody here is going to deny that magnetism is a thing. But
if the entire Earth, if the entire Earth is magnetized, be it negative, positive, whatever, then that magnetism is the same across the board.
Yeah, okay.
So everything is affected according. Hold on. Everything is affected according to its molecular and atomic structure.
All right, let's assume that you're right for a sec, and the flat Earth has this electrostatic charge that's putting everything down. Why does it affect all objects the same? Why does it not affect? All right. Why does it affect all? Sorry, I rephrased my question. Why does it affect all objects the same? Why is there a constant acceleration for everything? Why would this cup, which is plastic, and USS nail clipper be affected the same when this is made of a highly magnetic steel and this is made of plastic? Why are they both going to be attracted to that electrostatic force the same?
They're not. Well, when you say the same, what do you mean by the same?
I mean, the acceleration towards the ground is going to be the same.
It's not the same.
But it is. Everything accelerates at 9.8 meters per second squared, right? That's the acceleration towards the ground. Right? We know that everything that we drop will accelerate. Right, let me
just depending on where you're at on the Earth.
Yes, yeah. But okay, so let's say we're just at one point, here in my front room, okay? The electrostatic force is affecting everything in this room with the same amount of force, putting it down. Why is my plastic cup accelerating towards the ground at the same speed as my steel nail clippers?
It's not.
But they both accelerate at 9.8 meters per second squared if I drop them. Right?
You're saying the cup drops at the same speed at which the other object does?
Yeah, everything falls at the same speed, Jan.
No, that is not
in a
true,
vacuum.
Craig.
In a vacuum, and for all intents and purposes,
Again,
in this room.
That is not something. And again, that is theoretical at this point. You cannot go to NASA and test that.
Yeah.
What they did in that. Hold on. My perception after evaluating that video that NASA put out is it's been altered. The feather does not fall at the same speed as the hammer. It defies the laws of physics. It's not something that we can actually test.
Sorry, I need to ask you about that very specific thing you said there. It defies the laws of physics. Please tell me which law of physics it defies.
Well, you're saying everything falls at the same rate. I'm telling you it doesn't.
That's not a law of physics. You just very specifically said, JM, that it defies the laws of physics. Could you please tell me which law of physics it defies?
Well, it would defy Coulomb's law of things being attracted to the Earth.
Coulomb's law is an electrostatic.
That's part of physics, is it not?
Yeah, but it
you
doesn't
can deny it's part of physics.
Yeah, but it doesn't defy those physics. If the effect of Coulomb's law on these things would react exactly as we expect it wouldn't defy any physics. I don't know which law of physics it would defy if they fall at the same speed. And the fact is, JM, it's a well known fact that there is an acceleration, averagely around the Earth. It does vary slightly depending on where you are on your but that basically about 9.8 meters per second everywhere on the planet. And it's a measurable fact that there is this acceleration. And we know it's 9.8 meters per second squared because when we do the equations around Newton's law of gravitational attraction to work out a force on something, that 9.8 meters per second squared always gives us the right thing. Now,
is that with an atmosphere or in a vacuum?
Well, when they calculate these things on a bridge, let's look at the suspension bridge, the Clifton suspension bridge in Bristol. When they built that, they had to calculate what load that bridge could take and the suspension cables were able to hold up.
So all over the place. We're talking about just dropping things.
Yeah, I'm trying to clarify my point, right? Let me finish my point, okay? So that law of gravitational attraction with that 9.8 meters per second squared, right? They used that equation to be able to calculate the load that the bridge, the Clifton suspension bridge, could take. And then they had to take into account the fact that the metal would expand and contract during the winter and the summer. And then they actually created a machinery to tighten and loosen the suspension. But they wouldn't have known to do that. They wouldn't have known how to do that if they wouldn't be able to calculate the load that the bridge could take. And that calculation, they wouldn't use Coulomb's law. They would use Newton's law.
Well, then they'd be fucked.
Well, I don't think so because the Clifton suspension bridge hasn't fallen down. I've been over it thousands of times.
Or they don't use Newton's law.
They do because that's how you calculate these things.
You actually don't know that. You're just assuming that because that's what you've been told.
So during
my point is, let's go back to the 9.8. Hold on. Let's go back to the basics. You said things fall at the same rate. Is that in a vacuum or out of a vacuum? Because if I take 10 pounds and drop it in a feather, you cannot tell me that the feather and 10 pounds are going to drop in this atmosphere at the same rate.
Now, obviously, in the atmosphere, you have atmospheric resistance. You've got air resistance. Right. So,
does weight change in a vacuum?
Let me finish my point, okay? If I was to drop this, okay, in the atmosphere, it still has that 9.8 meters per second acceleration acting on it, right? But it's also going to have the fact that this surface area is creating drag. Wait, let me finish my point, please.
Let him finish, JM.
All right, it's still got that 9.8 meters per second acting on it down, but the fact that it's got this surface area allows the air underneath it to create a resistance, and that is a force acting in the opposite direction, okay? So in the atmosphere, this is going to fall slower than this. But you put these things in a vacuum where there is no atmosphere to create an opposite force of the air resistance, they will both fall and accelerate at the same speed.
And yet they weigh two different things.
Yes, because gravity
That's why
doesn't...
it's bullshit, Craig.
Right,
there is no experiment that you can show me where things are falling at the same rate that are massively different in weight.
Apart from the one that you claim is fake, of course.
because it was come from NASA and it's been edited. It's been cut to hell.
Yeah.
It's,
Okay.
they
So
even changed the timing of it. So you're going to tell me as a film director and as a photographer that you would trust that shit? Are you kidding me?
Yeah, absolutely. And there's not just NASA. For goodness sake, what's his name? Action Labs has done it in his own vacuum chamber, and it shows the things falling at the same rate, accelerating at the same rate.
I can't speak to what he did. I haven't looked at his material.
Well, my point is that it's not just NASA that can show us this. All right. And when you do the
There's a big
calculation,
difference between dropping something inches from the ground and being stories above it with, say, a hammer and a feather.
So basically, your only evidence that this isn't true is personal incredulity and saying that the video is fake. Is that right?
My reason for not accepting this is because a hammer weighs what, 5-7 pounds? A feather weighs what? Maybe, I don't even know what a feather would weigh. But you want to say that those two things, because weight doesn't change in a vacuum chamber.
No, of course, there's mass times acceleration.
Therefore, they are still affected by gravity.
Yes.
Therefore, the heavier object, regardless of atmosphere below it, is still going to fall faster than the feather.
Got it. There's your problem. Right. This is very important, JM. All right. Gravity doesn't make bigger things fall faster. Gravity makes bigger things.
I never said. Okay. You make assumptions.
Let me finish what I am saying.
JM, let him finish.
Right. So you just said that you think you want me to believe that something massively heavy will fall as the same as something as a feather, right? Now the thing is, gravity doesn't make things fall at different speeds. Gravity affects every molecule of everything exactly the same. The only difference that gravity will give that feather and a steel weight in a vacuum chamber is that they will weigh something different. They both have the same mass. They both have their own mass, but they both have the same acceleration acting on every single molecule that is comprising them. Gravity. No. Don't interrupt. Don't interrupt. Okay. So gravity will not make a bigger thing go faster because it's not. The difference gravity is making is that it weighs more. They will still have that acceleration of 9.8 meters per second acting on them, regardless of their size. So in a vacuum chamber, everything will accelerate at 9.8 meters per second, regardless of size, because that is what Newton's law of gravity says should happen.
So it's affected by what Newton's law says.
Newton's law accurately describes what's happening. Let's put it that way.
Or you perceive it does.
Well, no, using Newton's law.
I have not seen evidence to support your claim.
You ignore it.
No, I didn't ignore it. I evaluated it and assessed it to be false.
Right. So your personal opinion is that it's false. That's nothing,
not my
JM.
personal opinion.
Yeah, you just said you assessed
it,
and you are not qualified to take apart pictures, and you certainly cannot forensically analyze things in Photoshop.
I am qualified to take apart pictures.
No,
absolutely.
you really aren't. You really aren't, because I watched you do it, JM. JM, you managed to prove that a painting was in fact CGI. Like, you took apart that picture of I think Juno probe going into Saturn or whatever it was, and you were like, "Oh, look at this picture! I'm going to prove to you, NASA, that this is fake," and NASA saying it's real. When actual fact, what you did was you showed that a painting was in fact not a real picture, because no one ever claimed that was a real picture.
Claim it was real.
They didn't. In that picture. JM,
when I took the picture off the... Wait, stop. Don't tell me what I did when I fucking did it myself. When I took the goddamn picture off the NASA website, NASA had claimed it's real. I don't give a fuck what it says now.
No, they didn't. NASA never claimed that picture was real. Like, NASA never claimed that. NASA said that it's a painting, JM. NASA have never said it is. And even in the video that you did of it, which me and team went over, it says on that picture that you've got an artist representation.
That's my problem. That's the very problem, Craig. NASA's representing it to the world as it being a photograph.
No, they're not. They're
And if
saying it's an artist's representation. They told everyone
They
it
are
was a
now.
painting.
They are now because we fucking called them out on it.
No, they never said it was real. I remember seeing that picture in a news article years and years and years ago, and it's saying in that news article it's a painting.
Greg, we're done with this. We're done. Okay.
Okay.
I
Yeah,
know what
let's
I
move
did
on.
when I did the
All right.
experiment. I know what I did when I pulled the fucking pictures off. You want to tell me I'm wrong because this website's been altered now and says something different than what it originally says. So I'm not gonna, I'm done with this palava.
I mean, in your picture on your video, that you've got the picture that you took off of NASA, it says on that picture, this is an artist's representation.
I understand that, but NASA said it's real.
Apart from the fact I just...
All right. Let's move on. Let's move on. All right. I have 3 questions left. First one's kind of a combined question. I'll be honest, I'm not smart enough to understand it. This is about Coulomb's law. So how does acceleration equal Coulomb's law or Coulomb's constant times mass divided by their distance squared? And the follow-up to that is why does the electrostatic charge, why doesn't the electrostatic charge fall off at a faster rate due to the 1 over distance squared law?
JM?
I butchered the question, so if you need to ask it again.
I think the question's asking, can you use Coulomb's law to calculate the same things as Newton's law, right?
I'm
no,
guessing
but I
so.
don't think.
I don't.
Yeah, I assume that's what they're asking me, and I don't have the figures nor the time to sit here and work all that out. If you'd like me to, I can, and try to do a video on it. But I'm not going to sit here and answer. It's a great question. It's a good question. I don't have an answer right now.
Okay. Then I'll do last one for Craig and then last one for you.
In
Craig,
fact, if you would,
during,
do me a favor and send me a copy when you get a chance, Blake. Send me a copy of that question.
Yeah, I'll Skype it to you as soon as we're done. Craig, during the debate, JM mentioned that for some of the various rotational observations through the gyroscopes and through the Foucault's pendulum, he mentioned that it doesn't actually do 15-degree shift per hour. Why?
In what, sorry? In the video I presented?
So the Foucault pendulum, and it was a comment he made as you guys were discussing it. That
right, I see what you mean.
The drift is actually less than 15 degrees.
So the drift of a Foucault pendulum isn't 15 degrees everywhere. Because it is equal to the rotational time over the sine of your latitude, and that's how you calculate your angle. Because obviously, when you're on the Earth, based on your latitude, the pendulum itself isn't going to drift as much because it's not seeing what's going on outside. So to calculate the actual the drift, there's a very specific equation which I can show in the after show, and it was actually on that video that I presented. That's a very bad explanation of why, but there's a calculation you use to calculate the drift of a pendulum and your latitude to figure out kind of where you are.
So then would it be accurate to say that there's only 2 places on Earth where you would get a 15-degree exact shift?
For a pendulum, yeah, I guess so.
Yeah, the
North
equator.
Pole, South Pole?
Yeah.
Nope.
No, it wouldn't be the equator, would it? It would be the poles, correct?
Yeah, because on the poles, it would literally be rotating directly like that, whereas at the equator, it's kind of rotating around the outside. So that's why, as you...
You got that backwards, Craig.
Right. As you go down...
Let Craig finish, then you can talk about it.
As you go... so if you're on it's measuring just that rotation there. But as you go down, the pendulum's no longer just swinging relative to the spin. It's taking the kind of the angular distance into account. So as you get to the equator, it's much different. And that's why you use, I'm pretty sure it's the rotational time over the sine of the latitude to actually figure out what the drift is.
Okay, so if I may, just not to interject too much, but if you could hold your globe back up. Right in front of you. So if you've got the pendulum on the North Pole at the top,
Yeah.
and it is swinging directly between you and me,
Yeah.
that direction does not change, but the Earth underneath it does.
Yeah. So, and that's why you would register the drift. Whereas if it's at the side, okay, and you start swinging it back and forward, the Earth's rotating so it's not going to change. Whereas if you're at the top there and the Earth's rotating and it's swinging back and forward, it's going to register that drift. So as you get more towards the equator, the drift of the pendulum gets less and less.
Okay. That's kind of what I wanted to clarify, just to explain, because JM had mentioned that every observation is less than 15. So, JM, what is your response to that?
My response is simply that a Foucault pendulum cannot be proven that it actually is picking up the drift of the Earth, as opposed to just moving in an orbital rotation. It's a ridiculous, again, another ridiculous assertion. It's as ridiculous as the fact that we're spinning at 1,100 miles an hour. What was that, Craig?
So some stickers that one of my subs sent me.
Oh, not flat. That's cool. I guess for non-flat earthers. It's as ridiculous as the Earth spinning 1,100 miles an hour, us traveling at 66,000 miles an hour, and there's no destruction on the other side of the Earth closest to the sun when the rotation slows down, because we're actually traveling in the opposite direction.
Okay.
Okay.
Last question, JM. This is based upon one of your earlier comments in the debate. When we were talking about math, and you stated that math can be manipulated to say anything you want. Do you have an example of that?
Sure. The unsolvable equation. And no, I don't have it in front of me. I'd have to look it up. But anyone who's done trig knows.
Could you just describe it?
No, and math is not my
Idiot's
forte.
Guide to it, because I've never heard of it.
Hey, Furball, I was the one with that Coulomb's law question. Do you mind if I ask it after you ask this last question, so I can get it right for him?
Yeah.
Right, thanks.
Yeah.
Let's
Can I just say, well, as a lull, thank you to everybody that has watched, liked, and super chats. I'll read out all the super chats just before we close out. But I do appreciate every single one of you watching. Thank you.
Okay, there's a list of unsolved problems, but that's not what I'm referring to. Basically, in algebra and trigonometry, there's a problem that's unsolvable because of the factors involved, and it's been years and years and years and years and years and years since I've done any realistic math class. So you asked me for an example, and that was the one most people that do algebra know what I'm talking about, but I don't have the actual equation.
Do you know of any other examples or anything you can point to where somebody has manipulated math to say what they want?
Well, yeah, 8 inches times mile squared. The gravity equation is another example of that. We're on two separate sides of the fences, trying to explain things that we think are real. The examples that, for example, the examples that Craig gave me of the ships that were apparently below the horizon. One, there's no distance in that example that I know that ship is X number of distant or X miles away, so that I know how much drop should be calculated for. I have a picture where I'm shooting the base of a mountain at 110 miles away. Do you know what the drop rate should be At 110 miles? That mountain should be hidden behind 1.5 miles of curvature. And I'm shooting the base of that mountain.
Is that in your movie?
Now, that's not possible. That's not possible. That's an impossible mathematical equation according to your math.
I want to see that because that'll be fun to debunk.
Oh, sure.
Okay.
Right.
Team Skeptic, did you want to ask your questions?
Yeah. There was so much wrong in that last diatribe. I swear I have so many questions, but I'm going to stick with the original ones that I wanted to ask, okay? Number one, and this is a new one because I had two, but I'm just going to add this one because it's relevant to the other two. Do you know how Newton's law of gravity was derived, and what was it derived from, without having to look it up on Wikipedia?
Then no.
Okay, that's not a problem. It was derived from Kepler's laws of motion. It involved nothing on Earth than simply making mathematical predictions based on what was observationally seen by Kepler. The second thing I want to ask is, do you know, without having to look at, and that's not me ringing a bell, so I'm being serious. Do you know what Coulomb's law is? Without having to look it up, just do you know it? Basic physics.
Coulomb, do I know what it is? It's electrostatic charge. What do you mean?
No, do you know the mathematical equation?
Do what?
Do you know what the mathematical equation is for it? Coulomb's
Yes,
law.
I do. I don't. Yeah,
Okay.
I do, but I don't. I mean.
Okay, it's
If
F
you're asking me to-
equals Coulomb's constant times. Okay, it's F equals Coulomb's constant times the electrostatic force of one object times the electrostatic force of another object divided by their distance squared. Okay, that's Coulomb's law. Now, that's a force, correct? That's a force. And you've quoted Newton several times, so you agree that F equals ma. Can I make that assumption? Would that be okay to assume that you agree that F equals ma?
The F equals
I'm sorry?
what?
Force equals mass times acceleration.
Basic laws of physics.
Force equals mass times acceleration?
Yeah, that's how you
Yes,
calculate
F
force.
equals ma.
No.
Oh, man.
And now we're not
Then the
talking
third
about like
question
on
you're
the
not gonna
quantum
get.
level of anything. This is just basic. You know, if I'm punching the wall, how fast my hand's going
Yeah,
and how much
this-
mass is in my hand equals the level of force I hit it with.
Okay, then yes.
Okay, great. Because this
the-
is something you've
the
said
reason I
several
said-
times in
hold
here.
on,
It's
let
fine.
me explain.
I'm assuming that. All right.
Define math.
Let him explain why
differently than
he
you do.
said no.
I
Sure,
said
sure,
no
go
because I define math differently than you do. So
Okay.
that's why
Okay.
I said no.
So, okay, that's fine. That's fine. So now let's take a look at this the last question. Okay, the last question is F equals ma, and F equals the gravitational equation now is going to be big G times m1 times m2 over r squared. Now we can rectify that equation and come up with the equation that acceleration equals the gravitational constant times the mass of the Earth divided by the radius squared. So that's why all things fall at the same rate. Now, can you do the same thing using Coulomb's law? If you're going to use Coulomb's law as the electrostatic force being the responsibility for the reason why mass accelerates towards the ground when dropped, how do you rectify that with those two equations? Because you should be able to do that. We can do it with the gravitational equations. It's impossible. It's impossible.
Just because
So,
you're saying it's impossible,
you can-
make it impossible. But
I mean, you could
but
try.
My point
Good luck. Good luck.
That's why I was saying earlier that the equation isn't fit for purpose to replace Newton's law of gravitational attraction, because
Oh.
you can't use Coulomb's law,
see,
the equation, to calculate the same things as
whole
Newton's law of
theory-
gravitational attraction.
the whole theory of universal gravity is already flawed.
Okay.
But no one's
the-
disagreeing with
the
that.
last question I had. I'm sorry. The last question I had was regarding the fall off of the electrostatic force. Now, would you say that the electrostatic force At what depth underneath the surface of the Earth, underneath mean sea level, would you say that the electrostatic force is generated from? At the surface or below the surface?
It would have to be below the surface.
How far below?
However below the.
I'm assuming it's going to be close to 4,000 miles below. Okay, because that's what
No.
the force is. Okay, that's how we know with the
No.
force of gravity. We can tell. We can take 2 points.
At
Hold on,
sea level,
JM. Listen.
Let
Let him finish, JM.
Listen, JM. At sea level, we're really talking about 4,000 miles above the center of the Earth on our globe model. Okay, so if we go up 100 miles and we measure what the gravitational force is there, we can take those 2 points and extrapolate how far away the center point is, what the radius is, just using those 2 points. You could do the same thing with the electrostatic force. It's essentially the same equation. So you should be able to do the same thing. So if the electrostatic force is generated at the surface of the Earth, then the fall-off rate would be much greater than what we see in reality. It would have to be generated 4,000 miles below the surface. Now, do you have any proof that there's an electrostatic generator 4,000 miles below the surface that generates an electrostatic force that's as strong as whatever the electrostatic force is at the surface of the Earth?
Before you ask me to prove one, you prove there is one. Like that's
You're
not
the one
really
saying there's an electrostatic force. You're the one saying there's an electrostatic force. I'm asking you for.
But yeah, but
I'm
you're-
giving you the
but
data
you're-
points that you aren't going to be able to get on your own. I'm going to give you those. Okay.
You are trying
And I'm
to
telling
put
you
me
with the
in your
equation.
box.
Wait,
You're
let
trying
JM
to-
No,
let
this
JM
is you
respond.
saying that. Okay, go ahead.
A molten core has magnetic charge or does not have magnetic charge.
No, our molten core doesn't
That's
have
a non
magnetic
sequitur.
charge.
No molten material has a magnetic charge. That is where
Boom, I can explain
basically the core of the Earth is supposed to be generating all of your electrostatic force and your magnetics, right?
that. No,
No.
no.
So it's not from the core of the Earth?
No, the Earth's magnetic field is actually caused by convection currents in the outer core.
The outer core.
These convection currents are literally caused by the heating up and cooling down of stuff
You
as
can't
it
prove
goes.
you cannot prove any of that. Let's move on.
Okay, I think that's about it, isn't it?
Skeptic.
Yes.
Let me see if I can dumb down your question, because again, I'm dumb and I don't understand any of that. But basically, with JM's supposition that it's electrostatic forces that cause gravity, with the two different equations, with the with Coulomb's law, for the drop off of what we see gravity dropping off, and for the gravity levels we see at the surface, using Coulomb's law, which works on the surface for electrostatic forces in between individual objects, that electrostatic generation would have to be 4,000 kilometers before the surface for that formula to be correct. Is that what you're
just
you're
like
saying?
it is for gravity. Yeah, just like it is for gravity.
Yep.
Because see, we can take 2 points. We can take the 2 points
Unless
at different
it's
heights. and
generated
we
at
can
the
extrapolate.
surface.
Well, if it's
But if it's
that's
generated
the
at
last
the
thing
surface,
you want to have,
then it
JM.
would-
If it's generated, yeah. Go ahead. You're
Yeah,
hitting my point. Go ahead.
If it's generated at the surface, then that equation doesn't work because the forces and the drop off that we see would be different. But that formulation
JM,
works on the surface in between matter.
Let me.
Can we save some of this
JM,
for the
let me
after
give
show?
you-
I'm not staying for the after show.
Oh, come on,
I've got-
JM. It's going to be fun.
JM, will you?
No,
Hey,
Craig,
will you come
I'm
on my
not-
channel in the future? JM, will you come on my channel in the future? I will have this conversation with you. We'll only talk physics. We don't have to do any kind of name calling, any kind of nothing. We'll just talk physics. It's not even a debate. I just want to talk physics with you and get some shit straight.
I'm
because
not-
there's
I'm
certain
not co-
things that
okay.
I think you're fundamentally wrong about.
Of course you do, and you always will, okay? Because you've never stopped to take the time to look at the science on the other side. You've just assumed that we're all don't know what we're talking about. My issue with you, team, is the fact that you've never bothered to fix our relationship. That's my
We
issue.
don't have a
with you.
relationship, JM. JM, when you
No,
were
I
on
know
my
you-
channel, hey, JM, listen, when you were on my channel, did I mute or boot you any one time? Have I let anybody time you out? Did I let anybody fucking silence you in the fucking chat, hide you in the chat, anything like that? Yes or no? Simple question. I already know the
but I
answer,
was
so you might as well
polite.
answer it
I was
quick.
polite on
Okay,
your
great.
channel.
So when we were on Nathan Thompson's channel, not even your fucking channel, you fucking muted and booted me. When I went into
'Cause you
your
were being a
live stream the
dick.
other day and I wasn't being an ass, no, when I went into your live stream the other day and I wasn't being an ass, I simply asked one question. Your people muted me and hid me the whole time. You didn't say shit.
Wait,
So don't
wait,
talk
that's
about
not
that
true.
cognitive dissonance bullshit.
You
Why
do
don't
it.
you just
You
man
jump
up,
the fuck
man
out.
up and
Hey,
come
You
see
jump
me?
the fuck
Man
out.
up and come see
Team,
me.
you jumped the fuck
Hey,
out
hey, guys,
and
let's
didn't
take-
actually
let's-
bother to wait to see, because later on, let me finish this. Let me correct his ass.
Man the fuck
Because
up and
actually,
come
I
see
went
me.
and told my mods. I corrected my mods. You can go ask Nathan Thompson. You go ask the people. I did. I corrected them after you left and said, hey, because I didn't even know what happened until right before you bounced. But I said, guys, do not bounce any globe earther
I didn't
just because it
bounce. I
disagreed.
was there
I
the
said
whole fucking time.
that. Why don't you
listening
be
to your
honest and
damn
tell them
live
actually I
stream.
did stick up for you? Then tell the truth.
I
and
was
tell the
I
truth.
was no okay because I didn't hear that because I was dealing with being fucking hidden constantly in your fucking chat.
Okay, 'cause
In fact,
I
other
unmuted
people
you
on this live
twice.
stream right now in their
I
fucking chat.
unmuted you
You
twice.
didn't unmute me. You didn't. You cannot
I un-
unmute me. You
I
can
unblocked
unhide
you.
me, but you
All
cannot
right, guys.
unmute me.
Whatever.
Believe me,
Whatever.
dude.
Can we
Let's
move
take
on
this
to
to another
should we-
forum, guys.
Can we move on to final statements?
Let's
maybe?
take this to another forum. Yeah. Rather than
Well, the
end this
invite's
with a
open,
yelling
Jane.
match, let's move on
If
to
you're
final
not scared,
statements.
I'll be nice. If you're not scared, I'll be nice. I'll treat you like a man. We'll talk
I'm
physics,
not
and that's
afraid
it.
of you, Team Skeptic. I just don't know that
All
you're
right,
worth
let's
my
move
time.
on, guys.
All right.
All right, guys. Let's
Because
move
I'll
on.
prove you wrong.
So, Jam,
Bottom line.
do you want to go
Yeah,
first
that's it.
or second for your closing remarks?
I'll go first. That's fine. Whatever.
That's fine.
So I'm Joshua
Okay.
Michael, JM
You got-
Truth. You can find me at jamtruth.com or JM Truth on Facebook. I have a film project that I'm working on called The Plain Truth. You can find us at theplaintruthmovie.com or on Facebook also at The Plain Truth official documentary page. I want to thank Craig for having me on and debating me and inviting me on. It's been a long time coming. I know we've been trying to do this for a while. I've had a busy schedule. I want to thank Blake for moderating and Team Skeptic for being here. And I really don't have anything against the team. But anyway, I will talk to you guys
Then
later.
Come see me on
Thank
my
you for having
channel. I'll
me.
be nice. Hey, I'll be nice to you, bro. Come see me on my channel. I'll be nice to you, and I'll make sure that everybody
You
treats you
come
with
and make
respect.
peace
in
with
fact,
me and we'll
it'll be
talk
just-
about future things.
Bro, I'm here telling you that shit doesn't bother me. I am ready to have a conversation with you, man to man. That's all we'll do.
Team, if
No
it didn't
ad
bother
homs,
you
no
wouldn't get
nothing.
all- You wouldn't get all emotional about it, okay? Let's not lie.
Bro, yes or no? Would you come and fucking have a conversation with me? It doesn't have to be tonight. It can be in the future. We'll give you time to set up and get all. I'll even give you everything I'm bringing to the table ahead of time, so you have time to prepare.
Okay, I'll tell you what. I'm going to have to run this by my wife because this was meant to be my last debate because I'm not doing these anymore. These are completely against building bridges and trying to make peace between the communities, which is I'm more interested about the truth. So I'm not interested about running around in circles and arguing with every Tom, Dick, or Harry. So I will ask my wife if she's okay with me coming on, then fine. But I made a promise to her and I made a promise to my family. I'm doing a film project right now, and I can't be running around doing this all the time. I just can't. I'm moving 3 families right now. I've got a film project that is actually, if you went and looked at it, is a huge ordeal at the moment. And I've got tons of stuff that I'm doing. I'm just not interested in fighting everyone about the flat earth. I'm really not. I've got a website that I put together called jamtruth.com where I've got a lot of facts and a lot of things on there. That's why I put that site together, was to try to get people, the basics before coming and talking to me. So that's where I'm at the moment.
Okay.
Okay. All right. Craig,
All right. So
closing remarks.
I'll use my closing remarks to read out super chats as well. I just want to say thank you, JM, for coming on. I think you're wrong about everything you've said, but it's been as civil as possible. It's been fun. Thank you very much, BM, for moderating and team for being here and helping out as always. It's always appreciated. Thank you everyone for watching. I think I presented evidence to to back up everything that I said. And I can continue to present evidence that will just be ignored by flat earthers all the time. But you know what? It's fun, and I love doing this for you guys, and I'm not going to stop. So I'll quickly read out the super chats. We start with Recovering Alabamian, $2. So glad to hear a coherent presentation, FTFE. Thank you. $2 from Earth is Seriously Flat. My favorite flat earther. Pseudoscience is what globe zombies know. Just actually, there's going to be an after show after this. I know you say you don't want to be on, JM, but you are welcome. And obviously any other flat earther is welcome as well, including you, Earth is Seriously Flat, because we're due a talk. $2 more from Earth is Seriously Flat. Love is bombarding children's website with flat Earth. And another $2 from Earth is Seriously Flat. Are you a globe posse zombie swallowing NASA caca? $4.99 from Jen Morgan. Craig, end this. Let the man have his remaining dignity. He's toast and you know it. Be kind here. He is drowning. He's talking to himself. $5 from Hello 420. If you truly believe in the flat Earth, did the game Ark have everything more right than your model? Oh, I lost too many hours to Ark. And why don't you just use that as a model? $2. Oh, Earth is Seriously Flat again. Nathan Oakley is the best globe zombie slayer. Well, he would be if he could actually come out and debate someone, but he's chicken. $9.99 from Paul Schumann. JM's debunks are proclaiming FTFE's proofs are false because reasons. 10 BAM from Nenad Cubic. I hope in the future you debate Flat Earth with at least one positive claim backed up with some evidence for Flat Earth. This is too easy for you. $5 Canadian from Christ Puncher. The sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side. Is that true or false? Yeah. Peter Price. 140 ZAR. Can someone tell me what ZAR is? Z-A-R? I've never seen that before.
South African currency.
Ah, so I've got
I got somebody to give me a ZAR also.
JM, we cannot take your presentation seriously when it said mass attacking mass. Oh, did it? $2 more from Earth is Seriously Flat. Love is bombarding children's website. And another $2. So sorry, globe zombies, there's no Curvizon. And another $2 from Earth is Seriously Flat. Deflating the demonical blue marble one zombie at a time. You know what, Earth is Seriously Flat? I didn't get that. Maybe we do a few more super chats. $5 from Christ Puncher. JM, do you think you're smarter than Einstein? $5 from Area 85 Restorations. I can answer his ISS question if you want. I wrote a term paper on the subject for my heat convection class. Awesome. $5 from Candora Man. Why take someone seriously who thinks the Mux and Morley is one person and that the aether is the atmosphere? $7.99 Australian dollars from Stephen Yock. Whoa, you guys have been so patient with JM. He thinks you're being difficult. It's sad to watch him do this to himself. Another $2 from Earth is Seriously Flat. Farts under pressure equals globe zombie mentality. $1.99 from Schrodinger's cat. Can JM explain conduction versus convection? That's for the after show. $2 more from Earth is Seriously Flat. Demonic spinning balls. Indoctrination is dead. $5 from Jeffrey Greyjack. If people cannot go to the Antarctic, how did 138 people complete the 7 summits? $2 from Earth is Seriously Flat. Don't procreate with pseudoscience globe zombies. $2 from Earth is Seriously Flat. It was all a demonic spinning ball joke. $1.99 from Stephen Steen. FTFE is trash. Hashtag Team JM Truth for life. $2 from Earth is Seriously Flat. Pendulums are wrecking balls of the globe doctrine. $2 from Cajun Crustacean. Stephen Steen is trash. Hashtag Team Not Idiots. $5 from the Athens 619. The only illusion here is James' intelligence and his massive Dunning-Kruger. Then there's 2 more super chats that I think are from Earth is Seriously Flat that have been deleted for $2 each. $1.99 from Robert Williams. Ask JM if you have Coriolis without an atmosphere. $5 from Curtis Reynolds. If what he said was true about G's, it would have to be negative G's. $4.99 from James Collin. Craig did an amazing job. You were very concise and on point. Well done. $1.99 from Robert Williams. Ask JM if you have the same one. $2 from Christmer. Internal angles of a triangle 111. I've got a special video coming out about one of those recently. $1.99 from Stephen Steen. FTFE. Hashtag delete your channel. Hashtag Team JM Truth. $2 from Raven Zero. For JM, what is keeping the sun and moon in the air? $5 from Sparky NJ. The Earth is not negatively charged, otherwise electricity would not flow to ground. I'm an electrician. I know a thing or two about this. $5 Australian dollars from Bombay. If gravity is electromagnetic, why the hell don't we have hoverboards? Think McFly. €10 from Ural. When you ask, have you some maths to back up that baldy claim, he goes away with something like, sorry, Professor, my dog ate my work.
Electricity goes up and down, by the way.
Okay. £2 from Mr. E.J. Wheeler. 51,707 people visited Antarctica in 2018. $1.99 from Robert Williams. Does a bundle of sticks fall faster than one stick? $10 from Bombay. Possible clarification. The feather and the hammer will fall at the same rate, but the impact force and resultant force on the bottom of the vacuum chamber will be different. Very true. 10 Rons. All the Rons. I love getting a Ron Weasley. Lucy and Andreas. Best debate ever, guys. R.I.P. Flat Feet Pete. Shout out to Flat Feet Pete. Always remember. $5 from Curtis Reynolds. My comment about negative G's was in reference to JM's comment about the SR-71. Yeah, I think we got that. $1.99 from Stephen Steen. JM is the smartest person in the debate. Hashtag fact. $2 from Mama Murder 73. Having flashback of watching Numbers with P versus MP. $4.99 from Willie Merck. Team Skeptic, can you ask JM if he has knowledge of the Tubo-Decarn experiment? It's a meat tube variable. Just see if there's any more. $2 from Andrew Stoll.
What's the name of the experiment? I want to see what he's saying. What was the name of that
Tubo-Decarn.
Tubo-Decarn. Okay.
Yeah.
Tubo-Decarne. That's what it's supposed to say.
Yeah.
Meat tube.
$2 from Andrew Stoll. JM on Team's channel and give us a physics lesson. Yeah, I'd like to see that. And $10 from Stringer News 1, executive producer. Was there a single positive evidence of flat Earth? No, I don't think there was. Yeah, I think that's everything for tonight. Well, we're going to have an after show. I'll set that up for, say, 3 a.m., so in 15, 20 minutes. Everyone, the normal folk, will get an invite. JM, I will send you an invite. You're welcome to come in if you want. Any other flat earther?
Send me an invite if I can. I will. But
cool. Any other flat earther that wants to come in, try and let me know. Email me at fighttheflatearth@gmail.com and we'll get you guys in. Again, thank you, Blake, for moderating this. I know it's really early over there in Korea for you. What time is it right now?
It's 10:45 a.m., so I've got to get dressed and go to work.
You're like an hour and a bit late, man. You're the boss. Never mind.
Yeah, I'm the boss. It doesn't matter.
And on Wednesday is going to be our first science and satire stream. We're looking forward to that. But apart from that, guys, we will see you all in about 15 minutes.
Hey, Craig.
Yeah, man.
When you put this out, would you please hold on one sec? When you put this out, would you please, before you put it out, block? I accidentally hit the camera. I had my daughter in my hand. Would you block that out, please? If you can.
Yeah. I don't think it's on the camera, but I'll make sure I go through, and if your daughter's on the stream, I'll put a blur over her face or something, okay?
Thank you.
Right, no worries. Absolutely. Team, what were you going to say?
Yeah, so my brother has confirmed for Friday.
Nice.
He's a climate change denier. So we're going to have my brother on Friday on my channel, and I just want everybody to know that. So if y'all want to come and watch us have a good time, we'll be destroying my brother's claims that there is no such thing as climate change.
Yeah, that's fun.
I would actually love to come on and talk about anything other than flat Earth at times too.
Yeah. Sounds
good.
You're welcome to join him and be on his side. You're welcome to be on. Are you a climate change denier too?
Depends on how you define climate change.
All right. That's a big
You're
question.
welcome to be on his side. You're welcome to be on his side. Would you want to do that? You want to come on with my brother? My brother will stand up with you. He don't give a fuck about standing up against me.
When is it?
Friday.
It'll be Friday evening.
I'd have to look at my schedule before I can get back to you.
All right. Well, my brother's going to be there regardless.
No, that's fine, team. I've got other things that are more important than getting online for 2 or 3 hours and arguing. So,
bro, I was talking about my brother there, not you.
I'm just showing you. I just don't want you to think I'm
not there regardless. You're more than welcome. Right. Hey, man, look, this had nothing to do with you. I'm saying you're invited. That's it. You're invited. You're welcome to show up if you'd like. Cool. I'm not saying that you're great.
Thank you, team, for being here. As always, it's always a pleasure to have you on. Thank you, everyone, for watching. We'll see you really soon. I hope you've enjoyed that debate. I really enjoyed myself. Remember, stupidity is not a